suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. tight. Yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping light. suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.
Hey, good morning, evening, day to everyone. How are you doing?
Good morning. Woo woo. Are we excited today, guys?
Sure am.
We are super excited, and the day is still out, so looking forward to the next hours.
No,
Yeah,
it's
it's gonna
almost
be
dinner
amazing.
time, Sergey. It's almost dinner time. So, what I'm looking forward to today, this is a conference about machine learning. And as I'll tell you later on, I'm not into machine learning yet. But why is it not called machine teaching? We're teaching a machine stuff. We're not learning anything, we're teaching the machine.
You
Can
are
someone
teaching
explain?
the machine something. That is so true. But the machine itself is learning, right? So it's from the perspective of a machine. You know, machines have feelings too, or do they?
Shall I call you Wally then?
Please do. I would love that nickname.
Oh, what do you think about this, Sergey?
Yeah, you can only teach machine if you have something to teach this machine. But who are you? Like, who are you to teach this machine?
Well, I'll explain. Let's get to it. So let's get the show on the road. I am Metin Parzinski. I am a front-end developer at Passion People here in the Netherlands in the lovely city of Purmerend. I have been working with machine learning since this Monday, since I started at a company called Aidence. Aidence is a medtech startup that analyzes CT scans to detect early stage lung cancer. So I'm really happy to be using my forces for good. And yeah, now this whole event became super relevant for me to join. And now with this whole Corona thing going on, it's what I think is really cool that I just learned this Monday that Aidence is also trying to learn, like they have this technology to look at lung scans from CT, and now they're also trying to detect COVID. So that's super nice, and I'm really looking forward to working there and doing some machine learning. So Sergey, who are you?
Yeah, it's funny that you mentioned like patient people. Actually, I work with fashion people. That's kind of close by, but from different direction, right? So during the day, I build products with help of machine learning and data. And during the evening times, I'm machine learning Google developer expert, engaging with communities and do some open source stuff. So definitely looking forward to see what's going to be in the next days. What about you, Ajay? Like, how are you connected to machine learning?
Me, I also have like a Jekyll and Hyde relationship with machine learning too. So my name is Ajay Hawthor. I am an associate data scientist at the Goat Group, which is an online sneaker marketplace where you can buy and sell shoes. So on the day, I do that day job. And in the night, I manage an educational YouTube channel where I teach artificial intelligence, machine learning, data science, deep learning, all that good stuff. And I'm on a mission to make this world a more intellectual one.
So are you talking about this world? I guess that's what you're talking about, right? Well, as you can see here, there's this world map with all sorts of nice dots, and this represents the people that registered to watch here today. And as you can see, we have basically every time zone represented. So if you're having breakfast, enjoy. If you're having lunch, enjoy. If you're having brunch, enjoy. Maybe you're having dinner or a midnight snack. Well, enjoy today, and happy that you set your alarm to join us or you're staying awake. So if you're like in Australia and it's in the middle of the night for you, just 5 more hours before you can go to bed. Happy to have you.
And if you think those are just blue dots on the map, random blue dots, you are wrong. Those are actual real people all around the globe trying to learn something about machine learning so they can teach their machines, as Matthew mentioned before. So I'm really excited to have like more than 5,000 people in the same conference, right? Because it's actually quite democratizing to have so many people at one event. If you would remember pre-Corona time, for fitting 5,000 people, we would need quite a big room. And with today's regulations, we would need like have even more space. So no safety regulations to break today, and hopefully a lot of content to enjoy.
That's awesome, guys. And those are actually some really amazing stats. And we're able to have so many of you here today because of our diversity sponsor, Firebase. They allow people of different social and economic backgrounds to have more easy access to the paid tier. And maintaining this diversity is extremely important to us. So thanks a lot, Firebase.
Yeah, so we discussed already about attendees, right? But what about speakers? How did they select them? So I would tell you that it's not an easy task, right? I was trying to help the team to do that as well. So how did we solve it? We collected a bunch of people that we call program committee, and those bunch of people were meeting up almost like on a weekly basis and trying to select best of the best speakers. So I just want to say thank you again to Gan, Sayak, Dmitry, Eve, and Yuri for doing a great work. So I'm looking forward to see how you're going to like our speakers, and please give us your feedback afterwards.
So besides our diversity sponsor, we have normal sponsors also. And once again, we would not be able to have this kind of events without them. So big thanks to Microsoft, Toloka, MathWorks, Infinite Red Academy, Focus Reactive, and once again, Firebase. Thanks a bunch.
Yeah, and as you know, conferences is not only about watching people on the stage or by your screen as you do right now, it's also about talking to the people in the hall. And for normal conferences, we actually have rooms and halls, right? For online conference, we have the internet. So if you would like to engage in a conversation and you use Twitter, please use hashtag MLConf EU. This would make your conversation more visible to other people and hopefully going to get you some retweets as well.
Wow, that's some great connectivity via social media, guys and girls. And for more information about the conference and agenda with timings, visit MLConf EU. Now, here's a screenshot of like what the navigation on your website is going to look like. So the main screen here is the video player that you'll see the live feed. Towards the bottom, we've got a timeline of events that happen in the conference. On the top, you can access like the Remo, which is the social media conferencing tool. You can access the Discord and also even the conference schedule. So basic question, how does this conference work? Great question, audience. Well, we'll first start each session of the conference by first introducing the speaker. Then the speaker will give their talk, then join a Q&A session with the MCs. That's us. Now, if you're a part of the full access tier, you will also have access to speaker rooms and discussion rooms, which we're going to explain shortly. Now, this is probably a lot of information, but if you are lost at any point, feel free to click on that little question mark on the top, and we'll definitely help you out because we're very nice people.
Speaking of nice people, there's more than us. There's all sorts of nice people. So we have virtual watch parties prepared for you. For this, we have a tool called Remo. You can find the link up top above the player on the website. So if you join Remo, you'll see basically this view, and it's like a big conference hall, right? So this is the top view. You can sit on a table with other people and enjoy the conference together. So when you join, you'll be seated at a random table with other people. If you want to switch your table, you can just double click on another table and join that group of people. You can join with or without video and with your microphone so that you can interact with the other people on your table while you're watching the video stream together. So you can have a discussion about the content and the learnings you're doing. So once again, this is the top view, and you can click on the video to expand that video of the talk that's currently happening. So this is a lean forward type of situation. Even though you're watching at home, maybe you're not at home, maybe you're on the couch somewhere in the middle of the park, I don't know. But however you're watching, you can still socialize just like in real life.
Yeah, if the table sounds too intimidating for you, or you don't know like what table to join because there are like too many of them, we have you covered as well. So we have Discord that allowing you to send some textual messages and talk to all people at the same time. Additionally, the same tool is going to be used for asking questions to the speakers. There is a special channel called ML Q&A, and during the talk, please write the questions there. At the end of the talk, we're going to ask your questions to real speakers, and your question is going to get answered. So yeah, it's a tool that we have. Fun fact, Discord originally was used by gamers, and those days AI is actually using pretty actively games as an environment for intelligent agents. So now we are part of the game with artificial intelligence. So let's win.
Wow, we really came full circle on that. And speaking of Discord and any kind of social media interaction, we want to assure you that everyone should feel safe and have a good time during our event. So first, we encourage you to read our code of conduct at mlconf.eu/COC. And if at any time that you see somebody being harassed or you were harassed yourself, either on Discord, the discussion rooms, or anywhere in the conference, please reach out to us at coc@gitnation.org, and we'll help you right away. We want you to have a fun, educational, and carefree experience.
Yeah, like I mentioned, we have the remote to be leading forward, but there's also discussion rooms, which are also super nice. So today there's 2 discussion rooms and tomorrow another 2. Today we have one about Keras and TensorFlow and another one about computer vision. Tomorrow there's one about reinforcement learning and another one about fairness and interpretability. So if you're into any of these topics, be sure to check out the timeline when these discussion rooms are taking place and join them if you want to join our experts, which are moderating these discussion rooms for a nice discussion about these topics. These discussion rooms will be taking place on spatial.chat. If you're not familiar with spatial.chat, I'll explain how it works. So when you join, you can once again turn on your camera and or microphone, and you'll see a top-down view of a space. Here there'll be floating avatars, and you can move your avatar around. And here's the cool part, just like in real life, if you get your avatar closer to someone, like in real life it would be your person, you can hear their audio more clearly. So just like in real life, if I get close to you, you'll be able to hear me better. If you move farther away, vice versa. So this is really cool and a really unique experience, and I invite everyone to join there on spatial.chat for these discussion rooms. And there's more stuff happening on spatial.chat, which we'll get back to later.
Yeah, floating avatar sounds cool, but what can be even cooler is like floating and blasting avatars. For that, we have Quake Tournament. So later after the talk, once you have like a good understanding of new topics, meeting new people, please join our Quake Tournament just in your browser, right? So you can make even closer connections with your people. If you don't like gaming or you're not aware how to play Quake, please fix it tonight. You can still join special chat rooms. This is also an amazing opportunity to just like hang around with the people, maybe meet the new ones. And remember, the conference is not only about watching videos or people on the stage, it's actually about making new connections and enjoying new people.
So maybe 1 or 2 or 500 of you are secretly looking for a new position. Good thing, we got you covered. So some of our sponsors have amazing positions available. So if you're looking for something new, be sure to check out MLConf EU/jobs and check out the amazing positions we have available at our sponsors. And once again, our sponsors are the ones that make this event possible. We have a lot of people also watching for free. And as you can imagine, it's not free to host this kind of events. So if you want to work somewhere that cares about these kind of events in the community, check out the jobs.
Speaking of our sponsors again, these same sponsors also have offered us some few goodies and some perks that you could claim at MLConf.eu/perks. Now, if you are interested in attending a lot of conferences like MLConf EU, but you're interested in like GraphQL or like Node.js or any of the, or like anything else, right? Consider getting a conference multi-pass so you can save a ton of money and participate in our amazing conferences to come. So visit getnation.org/conference multi-pass for more information on prices and events. It's a really slick deal and will be completely worth your while. And we also have a way to get these conference multi-passes for free at this moment. So you can play along for a competition that will start now. Just get your phone, just get your little phone, take a little selfie of you and your entire setup, and just show us how you're watching the conference. And whether you're watching on like a TV, a computer, a laptop, whatever it is, just tweet this selfie at us under the hashtag MLConf EU. At the end of this conference, we are going to pick 2 winners, and these 2 winners will, first we're actually going to shortlist a set of 10 winners where we think, okay, that was a pretty good selfie. And from this, we're going to spin a wheel from which we select 2 winners for a final raffle ticket. And the winners will get access to a free conference multi-pass. It's fun, there's nothing to lose, there's only to gain. So let's just have fun with this.
And about having more fun. It's also fun to receive feedback, right? From this fun, machine learning can actually learn, or you can teach them depending like who you're gonna ask. So please send your feedback also to us. In order to do that, you need to go to mlconf.eu/feedback. Please put what did you like, what did you maybe want to improve for the next time. We're gonna listen to those things and make even better event next year. Yeah, and again, without those sponsors that you can see on the slide, it would be really hard to pull off this amazing event. Thank you again for joining us and helping us to make this amazing conference. Cool. I mean, we had quite a bit of like meta discussions and mentioning all things about organization, but all of you are here not because of that. You are here because we would like to listen to amazing speakers. And I'm really happy to introduce the first speaker. This is Thomas Wolf, and he is going to be talking about NLP. And why NLP, right? Because on one hand, if you're getting burned as a kids, right? First we start seeing some things, right? But once we start seeing, we also start talking. And this is about language, right? So language is like really fundamental part of us being humans. And Thomas, together with his company, Hugging Face, did quite a bit of good things to this community and natural language processing. So please welcome Thomas with his amazing talk about how to use NLP for transfer learning and making it easy for other people. Welcome.
Hi everyone, welcome to my talk, and today we're going to talk about transfer learning in NLP. I'll start to talk a little bit about the concept, the history, then present you the tools that we are developing at Hugging Face, and then I hope you have a lot of questions for me. So Q&A session. Okay, let's start by concepts. What is transfer learning? That's a very good question. So here is the traditional way we do transfer learning. Is the traditional way we do machine learning. Usually when we face with a first task in machine learning, we gather a set of data, we randomly initialize our model, and we train it on our data sets to get the machine learning system that we'll use to predict, for instance, to work in production. Now, when we faced with a second task, usually we start from scratch again. We'll gather another set of data, another data set. We'll randomly initialize from our model, and we'll train it from scratch again to get a second learning system. And the same when we face with a third task, okay? We'll have a third data set, we'll have a third machine learning system, again, initialized from scratch, and that we'll use in production. So this is not the way we humans do learning. Usually when we face with a new task, we reuse all the knowledge we've learned in the past task, all the things we've learned in life, all the things we've learned in university classes, and we use that to bootstrap our learning, okay? So you can see that as having a lot of data set that we've already used to generate a knowledge base, okay? And now this gives us two main advantages. The first one is that we can learn with just a few data points, because we can interpolate between these data points. And this can help us do some form of data augmentation, if you want, naturally. And the second advantage is that we can also leverage all this knowledge to reach better performances. So humans are typically more data efficient and have better performances than machine learning systems. So transfer learning is one way to try to do the same for statistical learning, for machine learning. So we've done last summer a very long tutorial. There was a 3-hour tutorial. So you can check out these links. There are 300 slides, a lot of hands-on exercise, and an open source code base. So if you want more information, really should go there. So there are a lot of ways you can do transfer learning, but today I'm going to talk about sequential transfer learning, which is the currently most used flavor, if you want, of transfer learning. So sequential transfer learning, like the name says, it's a sequence of steps, so at least 2 steps. The first step is called pre-training. And during these steps, you'll try to gather as much data as you can, okay? We'll try to build basically some kind of knowledge base, like the knowledge base we human build. And the idea is that we can end up with a general purpose model. So there's a lot of different general purpose model. You've probably heard about many of them. Word2Vec and Glovey were the first kind of model leveraging transfer learning. They were word embeddings, but today we use models which have a lot more parameters, which are fully pre-trained, okay, like BERT, GPT, or DistilBERT. And these models, they are pre-trained as general purpose models. They are not focused on one specific task, but they can be used on a lot of different tasks. So how we do that, we do a second step of adaptation or fine-tuning usually, on which we will select the task we want to use our model for, and we'll fine-tune it on this task, okay? So here you have a few examples: text classification, word labeling, question answering. But let's start by the first step, pre-training. So the way we pre-train our models today is called language modeling. So language modeling is a pre-training objective which has many advantages. The main one is that it is self-supervised, which means that we use the text as its own label. We can decompose the text here, the probability of the text as a product of the probability of the words, for instance, and we try to maximize that. So you can see that as given some context, you will try to maximize the probability of the next word or the probability of a masked word, okay? The nice thing is that we don't have to annotate the data. So in many languages, just by leveraging the internet, we can have enough text to train really a high capacity model, okay? So this is great for many things, and in particular, low resource languages. It's also very versatile, as I told you. You can decompose this probability as the product of probability of a various view of your text, and this is very interesting from a research point of view. Now, how are the models looking? So there are two main flavors of model. They are both transformers, because transformers are kind of interesting from a scalability point of view. The first one is called BERT. So to train a BERT model, you will do what we call masked language modeling, which is a denoising objective. So we take a sentence here, we'll mask one token, and we'll try to predict this token back. So we project all these words in vectors. Then we will actually use what is the attention layer in transformer, which will do a weighted average of these vectors to end up with also vectors, but these vectors, they now depend on the context, which means that the vector associated to masked have enough information from the context to be able to predict back, or at least to try to predict back the masked word, okay? So this is how BERT is trained. You train this model to predict back the masked token. Now there is another flavor, which is called autoregressive or causal model. And these models, they look pretty much the same, but you can see that to one token here is associated the next token. So my dog, the token that will be at the end of the hyper column associated to dog will be is the next token, okay? So we need to tweak the attention here. We have to mask the right context, otherwise the model can just see the label here on the right. So these models, they are inherently less powerful because they cannot use the right context to do their prediction, but they have a lot more trained signal here. So they usually train faster. So these are the two main flavors of model. These are the two main flavors of general purpose model. Now, how do you do the adaptation step? It's pretty easy. These are the two advantages I show you. The first step is that we will remove the pre-training head. So we'll take these pink boxes that I showed you on the previous slides, and we'll remove them and we will replace them with a task-specific head. So if you do text classification, it can just be a linear projection to the number of classes that you have. If you're doing a more complex task, you can add a full neural network on top of it. If your task is very complex, like structurally different, for instance, you do machine translation, then you have to do more complex things. We'll talk about that a little bit in the next section. So let me show you two main examples of downstream tasks that we can tackle: text classification and generation. So here is an example for text classification to kind of show you how it works. Let's say we have a sentence here, Jim Henson was a puppeteer, and the task of our machine learning model is to predict if the sentence is true or false. So this is just binary classification, if you want, okay? So the first step will be to convert this input sentence in something that our model can digest. So our models, they can tackle integers, floats, they need numbers. So the first step will be to convert these strings into numbers. And there is one thing interesting here is that our models are made to be trained and to process basically open domain vocabulary, open domain corpus. They are made to be trained on the internet. So we have to handle some uncommon words. Here is puppeteer is a word that is definitely not very common in English. So the way we handle that is that we will cut this word in prefix and suffix until we know every subpart of the word, okay? So here, for instance, puppet and are two kind of common prefix and suffix. So they are in our vocabulary, and we can then just convert all this in our vocabulary indices. This is now the inputs of the model we saw 2 slides ago, the BERT or GPT. And as you remember, the output was a vector. Here, the output before the pink boxes was a vector. And we just have to project back this vector to 2 classes. So for instance, we pull them, put them into a linear classifier, and then we get the classes. So this linear classifier will be trained from scratch on our downstream task, okay? So it has to be quite small in terms of parameters if we want to be data efficient. But this one is pre-trained on the huge data corpus that we've gathered. So this one can be really used, okay? So here are two, here is a practical example on a classification task called TREG 6. So you can see more details in the slides of our tutorials last year, but basically you will see that just after one epoch, we already have an accuracy over 90%, which means that this is really data efficient. This data set, this TREG 6 is really a small data set, it's 2,500 examples. So this is really data efficient. And when you train for 3 epochs, you get down to an error rate of 3.6, which is the state of the art. Well, it was the state of the art last year. So you get the two things I was talking about, data efficiency and high performances, okay? Now here's a totally different example. So you see the variety, the diversity of tasks that this model can face. This is a chatbot setting where we have kind of a knowledge base. Our chatbot is pretending to be an artist with 4 children who get a cat and like to watch Game of Thrones. And now he's discussing with a user in an open domain setting. So the user said, hey, chatbot answer, hello, how are you? Then the user say, I'm good, thank you, how are you? And our dialogue agent, our machine learning model, is supposed to generate a reply which makes sense given the personality, okay? So you see, this is quite a different task because we have a lot of different type of inputs. We have kind of a knowledge base here. We have a dialogue history as well. And we have these utterance and even the beginning of the reply because we're generating the reply word by word. So we have the beginning of the reply that we should also take into account to generate the next word. So how do we handle that? Well, actually, we had a paper last year at ACL that you can check out. But basically, you can do 2 main ways to handle that. You can concatenate all this in a single input. This is one simple way to tackle this, and it actually works really well. Or you can duplicate your model and have several parts that process each type of input, and then you need to connect them together with cross-attention or a way to connect them. Okay. This is very different, but the idea is that overall, as you can see here, this is a competition we participated in at Hugging Face 2 years ago now. And you see we were really leading on the automatic metrics by a strong margin using this type of transfer learning approach. So a few words on trends and limit. I'll go fast, but yeah, there is a trend to bigger model. This is quite a big problem because it's narrowing the competition. There is some way we can reduce the size of this model, distillation, pruning, quantization. I won't spend too much time on this, but this is something we like a lot. These models have generalization problem. Even though they are big, they have really difficulties to tackle out of domain generalization. And there is basically a limit to text as a medium, which is that a lot of common sense is just not written down in text. And so this is a limit to just what this model can learn. And the main way we can overcome this is to use some database or image, or even to use human in the loop, okay? And now there is a last main problem, which is that these models, they are trained just one time, and it's very hard to make them learn new knowledge later on because they have this problem of catastrophic forgetting. And so, for instance, GPT-3, which was very expensive to train cost like 10 million. GPT-3 has no idea what COVID is. Well, COVID is such a strong element of our daily life today, okay? So this is too bad. So there's a lot of shortcomings. And at Hugging Face, we try to tackle some of these shortcomings. So what do we do at Hugging Face? Well, we try to democratize NLP. We start with as a chatbot company, building a game, and we open source a lot of tools while we were doing that. And actually this tool catch so much interest in the community that we are now fully focused on catalyzing and democratizing all this research level work. So we do that in 2 main ways. The first way is to knowledge sharing. That's why I'm talking today. And the second way is to open source a lot of code and to open source some library which let people leverage all these developments and develop better models on top of them. Okay, so let's see a few of our open source libraries, and this will be the open door for the question in the second part. Okay, so the first main library that you probably know is called the Transformers library, which is a way to access all the state of the art model. They can be used both for NLU and NLG in many languages. We have today really a lot of models in the library. There is all the model you know, probably BERT, GPT, and also more interesting model, more recent, DPR, Pegasus. XM Roberta is a great multilingual model by Lexicono and team. And there are actually, T5 is really a huge model. So there are a lot of them, very simple to use. We can talk about that in the question. And we even have a model hub where people can share their model. We have more than 3,000 models in many, many languages. So if you want to use a model for Finnish or German, they have like 132 different models you can expect, and you can play with them even in the web interface. You can try the model and see how they behave. This is at huggingface.com. Now we open source more recently a second library called Tokenizer, which do this first part that I was talking about, like the string, splitting the string in integers. So why did we do that? This was really a bottleneck in terms of speed. And so we decided to use some very low level Rust code, super fast to do that, to solve this problem. So this is now really a very fast step. It's available in Python, Node, Rust. Rust is a great language. And more recently, a few months ago, we open sourced a third library, which is called Datasets. So Datasets is our third library. And this is to tackle one last problem we discovered, which is that datasets themselves, they're kind of hard to access for people. They're hard to share. And we spend a lot of time rewriting the same processing code that people have actually already written a lot for their own dataset. So we decided to make a library to solve this problem, make it easier to share dataset and also to share metrics. Some metrics right now, some novel metrics are actually very complex to use or like to at least to install and to set up. Metrics, for instance, to evaluate natural language generation can be really complex. And so we decided it would be also good to make something very easy to share them, to upload them, to share them. So this is the dataset library with dataset and metrics. And it has a few really cool stuff. For instance, there is built-in interoperability with NumPy, Panda, PyTorch, and TensorFlow too. So you can use basically any type of framework if you want, well, any type of modern framework. It's also made specifically to tackle really large data sets. So if you have gigabytes of data, if you want to, for instance, train your model on Wikipedia, and some data that are your data set may be, for instance, bigger than your RAM memory, you can use this library because it has a lot of smart way to do on-disk zero serialization. So you just take 9 megabytes of RAM, for instance, to train Wikipedia. There's a lot of smart caching. If you process your dataset once, it's already good, and you won't spend time reprocessing it again. So you can check this one. Here is an example how you prepare. This is the full preparation of a training set to train a model on Glue, with the tokenization, with the padding, and you see this is just like 20 lines of code, and here you're ready to train this model. So it's made to be very efficient and everything be very visible at the same time. So same as the model, we also have a hub where you can access and even explore the data sets. So there is like a more than 160 data set now. There are also multimodal data sets with images. And so you can go to huggingface.co, explore all the data sets. You can see the station, everything, and you can even like see what's inside the data set in the web interface. Okay. So same here. You can go and check it out at huggingface.co. Okay, so these are the 3 main libraries, and I'm really happy to talk about any question you may have on them, and also any question you may have on the first part, the concept and the history.
Yeah, that was an amazing talk. Thank you, Thomas. And for our audience, please give him a round of claps, right? But since he cannot hear your claps, right, maybe please do virtual claps in community on Discord. So he actually share a bit of love and some feedback as well. Yeah, so with the talk, we really got like a good insights, but we also have like one question to you to ask before we're gonna go to Q&A. So for that, we're going to use menti.com. So please open your browser on your laptop or mobile phone and enter menti.com. There you're going to get asked for the code. Your code can be also read on the screen that you see right now, but I will also read it for you. This is 7967042. One more time, 7967042. And the question that we asked today, in order to get your opinion, is about leaky relu. If you're applying a leaky relu to Adam, what are you expecting, or what are you doing basically? Please vote it here, and after Q&A session, we're going to get results for this one. And now, let's welcome to this virtual stage Thomas for your questions. Hey Thomas, how is it going for you?
Hi. Good, good. How is it going for you?
Yeah, it's also pretty nice. I mean, sun is already a bit like out in Munich, but it's still quite a bunch of exciting talks. And you did kick off this conference pretty nicely, because I do believe that natural language processing, or language in general, is like one of those indicators how good we are at understanding this machine learning. How do you feel?
Yeah, definitely. I think what we've seen in NLP right now, I guess over the last 2 years probably, is that it has become really what we would have expected to become from the start, which means really the way to process knowledge and the way to kind of do reasoning, or what we hope would be like reasoning. And so when we talk about AGI, I think right now a lot of people think about GPT-3, which is a full text model. So I think this is really an impressive thing about how NLP is now the most exciting field to be in AI.
Yeah, and it's kind of funny, right? Because you're almost predicting the first question, right? And the first question is actually about GPT-3, and people asking like, hey, since you're expert in NLP, right, and your company driving such a good efforts in this regard, what do you think is like advance of GPT-3 in comparison to GPT-2?
Yeah, it's a good question. I think, well, one of the problems of GPT-3 is that it's quite difficult to access it. So I think we have not really evaluated the capability of GPT-3 like we've done it for other models like BERT or GPT-3, just because like a lot of academics did not really have full access to be able to investigate what's happening, what can you do with that, to be able to test it fully on a lot of tasks. So it's kind of hard to give you really an answer, right? What I think is what we can do is that GPT-3 behave in some way like an interesting thing, which is a retrieval, like a smooth retrieval engine over a really large data set. So you can do like, it's like having a huge Google search where you can search every pages on the internet and being able to smoothly interpolate between all these pages. So I think this is very interesting, and what we see is that you can do some pretty cool application with that. Like you can smoothly interpolate to generate like also code and to generate like a realistic looking blog post. Now, when you talk about like really reasoning, meaning, and things like that, I don't think there is really any deep breakthrough in GPT-3, but that's my personal opinion. Yeah.
Yeah, no, it's really good that, at least for me, it does resonate that you separate reasoning, right, from having a big database, right? Because sometimes we have feelings that our community or parts of our community going like, hey, if database is bigger, right, you can just solve all of the problems, right? And sometimes it's not really, having a bigger model, right, doesn't really mean that you suddenly like having like AGI, right? And it's good to remember, basically.
Yeah.
Yeah, so another question would be, just like from the audience, is also, there are like so many different size of the model, right? Even transformer based, right? There's GPT-3, right? There is like transformers, there is like Berta, Roberta, all kind of things, right? There's also more distilled versions of them, right? And when one machine learning engineer kind of like starts to work on the task, right? What is a good like rule of thumb how to make this decision process, right? And obviously there is no like one clear answer, right? But do you have like any, I don't know, mental model or like a framework, especially for beginners who may be working in the company that doesn't have like, a big machine learning group, right? But they're like one of a person to actually make the calls, right? How can we help and support such a person?
Yeah, that's a good question. I think that's definitely something a lot of people face. And I mean, the very practical thing about our team at Hugging Face, I think, is that we should help people do that, because I understand we have like, we're providing a lot of models, we're providing a lot of checkpoints, but it's really hard to actually see the one you should select, the one you should use. So so the first thing is that we will try to build some better tools on this, and we try to help you. But now for the quick answer, I think it's good to keep your good reflex, like your good routine, is that you should start with something simple. Like you should start with a smaller model, like starting with distilled BERT, for instance, instead of BERT, like starting with kind of something like small, and see how far you can go with that, with this compute efficient model, like a distilled BERT, a distilled GPT-2 or distilled Roberta. You test a little bit with them, and if it's not enough, then you scale up. Then you start to use bigger models, and you try to see if you need like a T5 or something like that. Yeah, but that's the typical thing. Huh? It's the same. You should always start with like a logistic regression before you move to like something very fancy and very modern.
Yeah, definitely. I can only agree with you, right? Because once you start with GPT-3, right, you can only make it like worse from there, right? So like, no way to explain it, right? Yeah. But maybe just like a random idea, because you're also building quite a bunch of tools, right? So right now, many companies building just like a model zoo, right? Maybe you can also have something as like use case zoo, right? That's kind of like showing like, hey, what is the space of problems, right? And how does they map like a space of models, right? And yeah, solutions. But again, just like a random idea.
Oh, that's a very good idea. I think you should come build that with us.
Yeah. I will try. Okay, so next question would be transformers, right? We have seen that transformers did reinvent or revolutionize the NLP industry at all, right? But how do you feel like about future of transformers? There was like some papers also about using transformers for like vision, right? Do you see that soon transformer is going to be like all around the machine learning or deep learning in particular, or is it going to find their own niche, right, and going to plateau from there basically?
Yeah, that's a good question. That's a timely question. I think this vision transformer was a very impressive paper, because it actually showed that what we've seen for NLP was also true for vision, which is that transformers are quite efficient, and they are really a nice model to scale to large data sets. So as soon as you start talking about transfer learning from a large data set, then you really want the most efficient architecture that you can scale. And yeah, I mean, I'm not a computer vision guy, so yeah, I don't really know why we only seeing that today, for instance. So I don't know if there was something unlocked, but yeah, I think they're nice. I'm pretty model agnostic, I would say. I think the underlying like strategy, like transfer learning, are something very deep and important. Regarding the precise model that we select to use, I don't care that much. If somebody finds something better than transformer, I would be happy to switch to these new models. But I think the idea of reusing pre-trained model is a lot deeper with deep consequences.
Yeah. I guess what also something happening in industry right now is not even using transformers or architecture, right? But more like use like weekly or unsupervised like learning, right? Because the big part, correct me if I'm wrong, of transformer or BERT, right? Or this direction was like, hey, we don't need to have like a big label data set, right? We can just reuse what we have, right? And by using the same ideas of like, hey, can we learn representation from the image itself, right? And all of ideas of contrastive loss, right? Might be something that will spark like another different directions, right?
Definitely, yeah.
Cool. One more question from the audience. It's basically around, I will rephrase it, but I hope I'm not going to lose this answer. So what you suggested also, like in your talk, right? If you can use transfer learning, right, you can try to start there, right, and try to, unfreeze some layers, right, and train it basically like gradually, basically to get the task, right. And the person is asking, like, essentially, what is how likely, right, that by you doing transfer learning, you would end up in this like local optima, right, of convergence, right? So you don't get like really something good, right, in comparison if you start with model from scratch, right, and you start basically training it all together, right? Because I mean, usually people hope that the more you like unfreezing, right, the better you kind of like getting, and it's almost like a smooth transition from, like really out of the box transfer learning, right, into this model that has been trained from scratch. Do you agree with this one, right? Or is there like anything that people should be aware of, and like any tips and tricks basically of advanced transfer learning on an NLP?
Yeah, there's a lot of things here. so the best resource, I mean, is probably so I had a link in my first slide on a long tutorial where we talk about that, and I also made actually a video I could share earlier this year on this question. But there is a lot of risk to fall in local optima. So we see that when you fine-tune BERT, for instance, you can get like a non-off behavior for some kind of, so for some random seed, the model just doesn't converge. It's just stayed stuck in minima. And for some other random seed, it really works well, which was surprising in the beginning. And a lot of people have been investigating what was happening, and you have a lot of tools now to try to avoid that. You have tools like something related to what you're saying, which is called mix out. Which is the idea that a bit like dropout, you probably want to you probably want to regularize your model. With dropout, you regularize towards zero, like you cancel some weights, and with these other things, you can regularize toward the pre-trained model. So you can have a smooth interpolation from the pre-trained model to the model that is fine-tuned. But there's a lot of other techniques that try to make some smooth interpolation to not be stuck in local minima. That's a very active area of research. And the other option, obviously, is to try to do some assembles, which work very well as well. But yeah, that's still quite open research question, I think. We definitely have not really understand everything what was happening here, and while it's failing sometime, while it's working very well in other cases, that looks really close. So, yeah.
Yeah. So maybe for whoever did ask this question, it's like a good topic also for research, right? So once you find some answers, right, please write an article or paper, and we all gonna read it later on.
Yeah, definitely. So.
Cool. Maybe like the last question, because it feels like that this conversation can be going on like for a very long time, but we still have a bit of like schedule. So how do you feel about NLP in smartphones? Like, is it something that already kind of like solved out and we already have like pretty good distilling, or are there like still great breakthroughs like ahead of us?
Yeah, I think it's a cool area. We have a few open source library actually on Swift Core ML with BERT that you can run on the iPhone. And you have a lot of very recent paper regarding a talk for next week, EMNLP actually on that. You can quantize model very efficiently. So yeah, I can see a lot of breakthrough coming there with very efficient model, keeping a lot of the performances that we have on PC, on the computer, but on smartphone. Yeah.
Nice. Awesome. Thank you, Thomas, for... Sorry.
Yeah. That was
Sorry.
really...
Yeah, sorry. Thank you again, like for your amazing answers, right, and also your talk. But also, I would like to mention again, like the work that Hugging Face does in open source. It is really helpful, and it does make entry barrier like lower for many people in this industry. So thank you again, and hope to see you somewhere around the internet.
Thanks.
Yeah, and if you still have some questions, right, and you would like to address them to Thomas directly, remember that we have the speakers room. For that, you just go to website, as Ajay explained to you early, and after you will find the link to the conversation with Thomas. That's going to be starting more or less right now. So please go ahead if you want to continue your conversation on NLP.
Yes.
Yeah, cool. Now we are back to our questions. If you remember, we used Menti, and the question was, if you're applying Leaky ReLU to Adam, what are you trying to do, right? Or what are you doing, basically? And it looks like that, yeah, this is actually funny, but it feels like it's the reality of life, right? 68% of you saying that you're trying to figure out ML concepts, right? Yeah, there are like too many nice words in machine learning, and sometimes people not really aware, hey, how Leaky ReLU like working with comparison with ReLU, right? And what's the implication to Adam? So it's definitely a good thing to discover. Cool. The next one is Ajay.
All right. Thank you so much, Sergey, and thank you, Thomas, for that amazing talk on NLP transformers and Hugging Face. Now, before moving on to our next speaker, I want to also just give a shout out to our gold sponsor, Microsoft. Now, MLConf EU would not be possible without our sponsors like Microsoft. and they provide an end-to-end service for machine learning from development to deployment. And it's a service called Azure Machine Learning, and I highly recommend you check it out. If you want to stay informed about dev news, tutorials, and other events, then subscribe to Microsoft.Source, which is their monthly newsletter subscription. Alrighty. So without further ado, let us now introduce our next speaker, Beryl Serbacek. So there are two social causes that she cares about: healthcare and earth care, or environmental care. She's finding ways to leverage artificial intelligence and computer vision to address both of these concerns. And her passion, her actual passion to save the environment is seconded by the fact that her favorite movie is a movie called Vegan, which was a 2019 production. She is self-taught in augmented reality and uses this with AI to, for apps that help farmers in basically vegetation and soil health. And this is a part of her initiative in her company called Create 4D. Fun fact, when she was young, she wanted to be a computer scientist. And here we are, full circle, coming here to listen to a talk from her on cutting edge computer vision technology. And well, it's amazing to see that we've come full circle. And with that, I'll pass the mic over to you, Beryl. And while we're inviting her over here, why don't you all go to Discord, give her in the community channel, give her a little applause, make her feel welcome, make her feel special, and hope to talk to you guys soon just after her talk. So with that, Beryl, I'll hand the mic over to you.
Hi, everyone. Thank you very much for registering to this machine learning conference, whether you are located in Europe or anywhere else on the earth. Thanks a lot for being here. I'm Beryl, and today we are going to see how we can make software, machine learning software, see things like human does. We will try to introduce some image processing and computer vision topics in this very limited short time. Because of the time limitation, I cannot show you so much programming examples, but within my slides, if you notice, I put some algorithms within boxes. So I hope you can turn back and look around later. That could be useful, and we can discuss more examples maybe after the presentation at the Q&A session. So this is my agenda for today. After a small introduction, I will first introduce you what is image processing, some image processing algorithms, and then we will look at computer vision. And we will see some classical computer vision algorithms. Finally, I want to address how we can combine computer vision and machine learning and how it is different than regular AI solving all problems by itself. So how is it different? Is computer vision irrelevant now because AI is doing everything by itself? So we will discuss these topics. And lastly, I will give you a piece of code. Again, you can implement yourself to jumpstart into doing some computer vision algorithms, hopefully. A little bit introduction about myself. I'm currently an assistant professor at a Swedish university called Jönköping University. It's an AI lab just focusing on developing AI and explainable AI algorithms. Besides, I've got my own company, which has done a lot of computer vision applications in the past in the Netherlands. I'm located in the Netherlands also, and I've got experience over 15 years in the area of computer vision, machine learning, and also artificial intelligence is the area where I'm putting a lot of efforts these days. If I want to introduce myself, I always need to add that I'm an environmentalist. So what is an image? Let's start with what is an image before processing these images. Image, if it's a digital image, we are talking about digital images, not old analog style images. If it's a digital image, we are talking about a matrix. The source can be anything. The source can be your smartphone a regular camera, it can be a satellite sensor, it can be a heat sensor, it can be dermatologic or microscopic image, telescope image, whatever. If we are talking about digital image, we are talking about a matrix. All right, if you've got a matrix, you know how to do matrix operations, and welcome to image processing. You know how to do image processing now. If we see a picture with a T within it, let's say, we can represent this T as an image by putting 1 when it's bright and putting 0 when it's dark. Now we've got T represented as a digital image. When the numbers are only 0 and 1, of course, this matrix is binary matrix. It's a binary image, it's called. But normally when we've got our smartphones make a picture, we've got RGB, red, green, blue color images. So that means that we don't have one image as a one matrix. For each image, we've got 3 matrices. But in order to make things operation simple, now we will try to look at one matrix at once. Assume that we talk about brightness or grayscale image, which is combination of these red, green, blue bands all together. Let's assume that a weighted sum is obtained. Then you've got the grayscale image. So before going further, I said I will talk about image processing, I will talk about computer vision. Are they the same thing or not? I said it's same. Is it true or false? Give an answer from your head now. It's false. Well, even though people use these terms interchangeably, some people say image processing for computer vision, some people say computer vision for an image processing application, but in fact, there are different things. When we say image processing, we assume that we've got a software, which we say image processing software, where the input is an image and output is a processed image. Then we've got an image processing software. However, when we are talking about computer vision, then our input again is an image, but the output is a value. It can be a number of people in the scene, or a vector, a position, a GPS location that we found in a satellite image, a boundary, a shape. It can be any class, for instance. So if we have a value at the end, then we say we've done computer vision. And most of the time, these are done all together, because most of the time the image for computer vision is not suitable to process and to be processed immediately. So it's a good idea to do first image processing to process the image, maybe removing some noise and make it more suitable to be processed by computer vision. And afterwards, computer vision extracts some values, shapes, vectors that later on you can pick them up and put them into a machine learning algorithm, learn something, classify something, recognize something. So we will see more examples. In image processing, we said our input is an image and our output is a processed image. What could be this? Just some examples of image processing algorithms. It could be denoised result. Maybe input was a noisy image and the output is denoised image. It's more smooth. It can be a color adjustment application done by image processing algorithm. You can do image augmentation, very interesting for generating test data sets for AI, for instance. Or you can remove the background like Zoom meetings are doing now, changing the background. This is also an image processing algorithm. You can do edge detection, corner detection, like you can do such methods by using image processing algorithm, but assume that you've got an image of the edge at the end. And also you can make old photos new by guessing what colors they should get at the end. And there's an example of pretty much like looking at old videos colored. And this is a result of image processing algorithm where image processing is applied to each frame of the video. So I will show you some image processing algorithms, but maybe the most important thing to express is histogram when we are talking about how to do image processing algorithms. Histogram is distribution of brightness values within the image, and it's the most interesting thing to look at in an image when you get it. For instance, here there's a scene that you see. If we put the histogram, we mean we are looking at the image values. If we are talking about 8-bit image, the values are from 0 to 2255, because we should have 256 values at the end for an 8-bit image. Each these values are telling about brightness level of the image. If it's very bright, if it's very white, the value is 255. If it's totally dark, the value is 0, and the other gray values are in between. If you look at the distribution, how much bright pixels there are in this image, if you look at the statistics, you see that some accumulation is happening close to 0, and some accumulation is happening close to 255 higher values. We can expect that these darker values, these mountain is causing this accumulation of darker values here. It gives us an idea about the values within the image and are they distributed nice or not. And we can also do more processes to the image by just looking at this histogram. The first important thing to know about how to do things with histogram is to know how to do histogram equalization. Most of the time when we've got input images, for instance, from a drone, it's looking at a limited area where it's also projecting its own shadow. We will have very dark values. First of all, we have to make sure that we have stretched these values good enough that we can see some texture, some properties within. Otherwise, we cannot do further computer vision applications to extract some features to recognize things. The first interesting thing to look at is histogram equalization. And it's trying to stretch the histogram to make sure that the distribution is done between 0 and 255, and we can see some texture within. This histogram equalization is easily done by looking at the cumulative values of the histogram. That means if we've got the brightness values distribution, we can count how many brightness values until this value in order to project this cumulative histogram. Then we can use this cumulative distribution in order to find the new values of each brightness by just using the cumulative distribution function as a projection function to find the new distribution, new brightness values to project into stretched values. So I hope you can find more at the references, but we use these histograms for making the image more visible. The features within itself are more visible, but we can also use it for segmentation. For instance, if we look at the histogram and put a threshold value, like you remember the mountain and the sea background, we can threshold the histogram in order to remove the background or to get the foreground only. We can use the histogram for segmenting objects as well. We can do this segmentation by looking at the histogram of the overall image, or we can look at small windows and choose different thresholds if the brightness is fluctuating a lot within the image. And the question is here is how to choose the threshold value automatically in order to find to do the segmentation. Don't worry, OpenCV comes with help because there's a method called Otsus thresholding, and OpenCV offers you just in one line. What it does is to, I draw it by hand here. If you get these brightness values, assume that they are distributed like in this video. I have to go a little bit quicker if I can. If you look at the histogram, what we need to do is to fit two Gaussians to this histogram. I can fit two Gaussians to two peak values that I found in this histogram, like this. And the intersection place gives me the threshold value to segment this image automatically. I have to go a little bit faster. We can discuss in the Q&A. We can look at more algorithms that what we can do in the area of image processing. We can use the brightness values in order to extract lines. How we can do that? We can use hysteresis threshold in called method, for instance. What hysteresis thresholding does is, instead of selecting one threshold like Otsu did, herein we select two thresholds. One is high threshold, the other one is low threshold. Then we are looking at connected pixels, and the connected pixels, let's say all of them are lower than maximum threshold, then we say we remove these connected pixels. They do not represent anything significant. However, if some of the parts of the connected pixels have brightness value higher than the high threshold, then we assume the all connected segment, even though some of the places were darker, we assume all the connected segment pixels as one edge together. So that gives us very robust algorithms, because one threshold may not detect all the connected lines, but two thresholds with hysteresis thresholding like methods help us to develop more robust approaches. So I've given you some algorithms to process images further, but I have to go quicker. Please look at the slides later. In order to do image processing algorithms, we can do matrix operations. Because image is a matrix, we said we can make a lot of applications by making a convolution window and scanning the image with a convolution window. Like, for instance, if the convolution window has only values 1, that means we put the average of the value within the window to each pixel when we are traveling, and at the end we've got averaged pixels, which gives us a smoothed image. If we replace this convolutional window, instead of ones, we put a Gaussian shape. That means the middle pixel is making the most influence when we are having the average. There's a weighted average now, and the more far away pixel is making the less contribution when we make the average. So that helps us to achieve two results which are smoothed, but the edges are not smoothed much. Edges are preserved at the end. I advise you to look at my slides later. I'm going to share, but it's also possible to make these image processing algorithms in the frequency domain by converting the image into frequency spectrum and then process it there by applying low pass filter, high pass filter, and then convert it back to image domain to achieve results. Anything that we've done here in grayscale is also possible to do in red, green, blue bands of the image directly, and maybe combine the results later. But the most interesting thing for the people in AI is to look at augmentation methods that we can do with the image processing methods to generate a lot of data that we can use. After processing the image, then the computer vision comes. Computer vision tries to extract important features. We call it local features, to look at the image to recognize things. In order to do so, we try to develop some methods which can identify corners, sharp edges, or specific texture properties, like Harris did with its algorithm, compared each small window with its neighbor to see if the neighbor made a significant change or not. Here is the map of the Harris at the top right side he obtained. If there's a significant change by comparing to neighbor, it's highlighted. Then when it's thresholded, he got corners at the end. This is Harris' algorithm. Then later on, other people proposed heuristic approach or bandpass filtering approach, which are more robust to noise effects, because Harris was not robust to noise effects. If there's a noise pixel, it's going to be highlighted at the end. Are features enough for recognition? No, I will answer for you. We need to describe each feature with a feature vector, which we call descriptor vector, in order to be able to do machine learning algorithms to learn or classify things. And please look at the descriptor vector extraction, and I give you within the source code box, which is offered you by OpenCV directly. And there are different methods to use descriptor vectors in order to recognize or match things, like directly matching with a template that we already hold in the memory. We can try to find the most similar descriptors within the image, or we can try to look at the spatial distribution of these descriptor vectors with a graph theory. And I gave you more examples, but before we end, I want to discuss how it is different than the AI algorithms that we know of. Does it mean that if we develop AI with more sophisticated algorithms, we achieve more? Not always. Sometimes computer vision and machine learning comes with more advantages because we hand tailor everything, and AI comes with other advantages. So I listed some comparison lists here, and generally computer vision allows us to hand tailor what we are looking at. However, AI finds the good features by itself. It makes things maybe more robust or generalized, but it might make things also more vulnerable to adversarial attacks when we cannot hand tailor what to look at significantly. AI always needs a large number of data set to learn from. However, as you see, if we are using computer vision, we can use only one image template to find the similar thing. With computer vision methods, it might be challenging to find optimal model because we show only one template. However, AI learns from large data sets. It might maybe find generalization better. And finally, for computer vision methods, you don't always need GPU, but with AI methods to find the optimal solution, you definitely need a GPU. So please go ahead, write the code that will open up your camera and grab an image that you can start using OpenCV algorithms. And this is a very short time. Unfortunately, I have to close it up now, and I'm very happy to go through your questions and open up the topic more. Thank you very much for inviting me. You can find more about how to access me at my website, my first name, surname.com, and you can find me on Twitter. Please subscribe to my YouTube channel where I teach a lot, and also my newsletter to get all the free content that I'm delivering every month. Thanks a lot.
with Brill, we have a polling question that comes from like the audience. So here's the question. Let me just pull that up right away. Alrighty. So let's say that you have a company, right? And you need a software solution for some object recognition that you want to do. So what source would you trust? You have some options below. And if you want to answer this question, go to menti.com and use the code 9471503. So I repeat, go to menti.com if you want to answer this question. You think you have a great idea? Just go to menti.com, type in the code 9471503 to submit your response. All right. And with that, I'm going to welcome on Brill now for the question and answers. Hello, Brill.
Hi.
How are you doing today?
I'm fine, thank you. Thank you.
Awesome.
Very nice to be here. Very nice conference.
Awesome. Well, we're all glad you're here. And we want to start this conference. Well, we've already started it, but we want to continue and get the show on the road with some amazing questions from our audience, right? Because they have so many questions for you. Okay.
Yes.
So here's a good question. Okay. So what are some examples of processing that can be done in the domain of like frequency and audio? Can you use OpenCV for that, for example?
Oh, for audio processing, OpenCV meant for Open Computer Vision. It stands for computer vision and doing image processing. So it's not meant for audio processing directly, but I'm assuming that you might find out maybe one or two functions just it ends up you can process 1D, one-dimensional audio signal too. As we've seen in slides, all the images that we are looking are two-dimensional matrices. So they are a little bit different than audio, which is one dimension and comes in time. So it's OpenCV, it's not meant for sound processing.
You're
For
right.
sound processing, I'm sure you can benefit some TensorFlow libraries, but other libraries, maybe it's good to look up further. It's not really my domain.
Yeah, that's actually true, because I know that the operation of convolution, although like you do tend to apply it to images and it's like the fundamental for operation for computer vision, we do have like one-dimensional convolutions for like signal processing as well. But yeah, that's true. I also haven't heard too much about it from OpenCV, but it's definitely like relevant in terms of fundamental operations. Yeah. And okay, so here's another question. I know that you introduced like some math on your slides while also explaining OpenCV, and I know for many people, mathematics could be very daunting. And like because of this, there are people who look at the math and they're like, okay, I don't want to get into this. Would you recommend people just starting directly with OpenCV and then do the math later? Or is there like some other approach to this computer vision that you would take?
Yeah, that's a very good question. First of all, just in my mind, I want to mention, I shared my slides. I think it will be announced on our website or Twitter, that the slides of this talk. You can use it for finding the references. I always put the link to read further. So maybe you can click on the link and check the code, check the source to learn further what you heard right now in this very short talk. Unfortunately, I cannot explain everything in detail. But when you're programming, you start doing things, it's really good to check the math. Otherwise, you will end up maybe with a good result with your programming, but is it really a robust algorithm which you can implement and works in real life? Or whenever there's an error, there's a false recognition, where does it come from? It wouldn't be easy to debug if you're not aware if what kind of algorithms behind, or you need to know the parameters of this function to tune them. But how do you choose the parameters if you don't know the math behind it? I'm not telling that you go and take a master PhD degree like something. Not everybody needs to do that, but I know very professional developers who really do robust, good stuff, just self-educated. And nowadays, everything is online. I would recommend maybe you're writing a code, it works good, but just go and check the math behind it on just on online, reading some blogs, forums, and asking questions there to other people. It would be beneficial.
Yeah, I completely agree that a good healthy balance between like the actual practical aspect with the theoretical aspect can do wonders in helping you understand exactly like what you're getting into. Yep. Thanks for that answer. And we have some more questions here too. And let me just pull some of them up. Okay, so do you have any ideas or techniques of computer vision that you would use in healthcare or farming or any of the other social causes that you care about?
Yes, a lot. In the healthcare field, I used it for recognition of cancer, skin cancer, and identifying whether the cancer area is malignant or benign. So, and what stage of cancer could it be? And for this purpose, I've done feature extraction, just inspired from doctors. They explained me how they look at skin and how they classify the stage of the cancer by just looking with their eye. Of course, there must be biopsy, but doctors have seen so many examples and they can just look and tell. And I was really curious, how do you look and tell? Explain it to me. When doctors explained me, I found a way to describe what they explain mathematically. Then it turned into a feature extraction algorithm, which could be used for classification of cancer stage at the end. It always inspires me to think of how humans look at this and how humans recognize, and can I find a mathematical method to do something similar?
Yep. I think that, yeah, that type of meta understanding of like being in the mind of like how a human would do this and trying to instruct a machine to do something very similar is very important. And sometimes it's also like very hard to get in terms of like healthcare, because I know like if you make like, for example, in cancer detection, like mistakes that you make can be more fatal. Like you're playing with human life. So there kind of is that, up and down of like, okay,
Yes,
is it
but
okay to use
in
artificial
healthcare, we
intelligence for
don't
this?
really want to be the decision maker, but want to be like a decision supporter to doctor always. That's in those kind of critical areas, we don't want to kick out the human being, but just want to be a supporter. And second thing, if you put 10 doctors, they will not end up with the same answer if you ask what cancer stage it is. They've got also some fluctuations in their answer. So maybe a machine learning system could be a way to normalize their answers and just to get a second opinion from the machine.
Got it. Yep. Thanks for that answer. And I think we have one more final question that we could get to. Right now, like maybe in your current work, probably in your startup in Create 4D, how are you currently using computer vision and even OpenCV for that matter in this work, in your current workspace?
Yes, it's very interesting to look at what's going on the earth, especially in agriculture area, since it's my passion to look at food security and how plants are doing. Do we have enough food soon in the supermarket or not? And the methods that I described in this talk, like simple convolution, help a lot to extract some features which might indicate a sudden change in a local area, maybe something wrong in this area, and I can go there, visit, and rescue the plants before they die or spread the disease to other plants around.
Nice. Awesome. Well, thank you so much, Beryl. I think we're out of time right now for questions, but I appreciate you coming here and just answering our questions and also giving us a good
a lot for
insight
inviting
into
me.
computer vision. Yeah, computer vision, everything. I mean, like, that's amazing. So everyone, by the way, if you wanted to go and talk to Baril right now, she will be available in her speaker room to answer your questions in the event that, you know, you couldn't get your questions out, at least in this Q&A session. So thanks a lot for joining us, Baril. It was great
Thank you
having you
so
here, and we
much.
will see you later in your speaker room.
Thank you. Bye-bye for now.
Bye-bye. And now, so before Baril actually spoke about her introduction to OpenCV and computer vision, we gave you all a question. So that question was, if you had a company and you needed a software engineering solution for like object recognition, which source would you trust? And pulling up some of those answers now, it looks like it's, well, it's almost unanimous that we would trust machines over people, because people have their flaws and clearly machines don't. Well, that's always encouraging to hear from an audience. And well, right now, thank you all so much for answering that question. We will be now taking about like a little 10-minute break. We hope you enjoy this little end screen, this splash animation that will come for the next few minutes, and we will join you shortly for some more amazing talks. Again, give our claps to our speakers, give a clap to Baril, give a clap to Thomas Wolf for their amazing presentations, and we hope you support them in the future too. So we'll just take a few minutes of a break, and we'll see you soon. Take care.
Fill me out with your smile. Now the sunshine brings the light.
Yeah, I hope that you had a bit of break, right? Maybe you do some stretching, right? Because it definitely helps to stay alive, like this entire conference. Yeah, so back to machine learning and back to even more amazing speakers. So as you know, as we mentioned before as well, like in order to train machine learning, right, you need to have data. Some of you are happy because you already have a data set with all those things. Some of you have like a new problem, right, that you need to have data set collected for you. And you can do it manually, right? You can pay like lots of money to lots of people, or you can use some of the services. One of the services is actually called Toloka. It's also happened to be our gold sponsor. So this is like a great largest, or it's actually the largest crowdsourcing platform globally designed by engineers for engineers. And it's allowing you to get very good data labeling at scale. I think there's also going to be one of the workshops happening on 11, so please join them and get to know how to label your data. If you're watching this conference alone, right, and you don't have anybody to discuss all what's happening here, please remember what Betty said in the beginning. We have this like awesome tool called Remo that allowing you to join some tiny virtual tables and talk to tiny virtual people. No, not really. People are actually real. It's just that avatars are going to be tiny. Yes, and with that, we're going to go to the next speaker. And the next speaker is Robert. Robert is actually coming from more software engineering background. But you'd be like, hey, but it's a machine learning conference, like what he's going to be talking about. And his talk is going to be, it's called the Evolution Revolution. That sounds a bit of buzzwordy, but he actually going to go all the way in and out, how to build machine learning, how to bring it to production, and what software engineering practices you can actually learn from machine learning and apply basically from software engineering. So please welcome and give some virtual claps on Discord and community channel, or you can also clap at home. Please welcome Robert.
Pleasure to be speaking today. I probably am the least qualified to be here. But that aside, I want to set up a scenario and we'll walk through it. And I want to propose something. So here's a scenario. There's Adam, right, for machine learning for what do they call it? A trainer. There's various words for it. You come up with this new idea, trainer, called Adam 2, and it's revolutionary. It's going to change everything with machine learning. And so you're like psyched about it. You want to get it implemented somewhere, and it's amazing because it represents innovation. And that's really what machine learning is kind of all about. Like we're innovating at a breakneck speed, and so we don't want things to hinder us in this arena. So here's our elegant and simple solution that represents Adam, and here's Adam 2. So yeah, it's amazing. You're going to see it everywhere, but there's a problem, even with just adding that one little number there, and that's this. It represents an engineering problem, the implementations that we have to manage. So I personally write in Node. I'm in charge of I'm rather the tech lead on the machine learning team. And for us to use this in Node, we would have to come up with translations in all these languages and potentially more if we wanted it to execute in these environments. So we've got JavaScript, WebGL, up and coming WebGPU, WASM, native bindings, perhaps TPU, and even new languages. So yeah, that's what you need to know to add that little 2 in there. And also, you don't want to forget about unit tests for each language because you want to make sure that your stuff stays together. And they don't tell you this when you're developing on the GPU or when you start getting to really close to the hardware, that there are precision differences that have to be managed. And that each implementation has various needs. And so they're going to need different abilities, different capabilities. And each one is going to eventually compound technical debt. That's just kind of how development goes. And that problem compounds because of those bugs. You have to fix them. The underlying languages are constantly being refined and changed, right? And they have to be managed. And to add that to in that Atom function, you have to go into those languages and actually alter them. And then what if somebody creates Atom 3? What does that do to Atom 2? Did they extend Atom 2 with Atom 3? If they did, and they use some sort of class structure, or maybe they can't because they use functional, depending on the environment, and each one's different. And so that leads to diverged code, because each code is different, and each code being different has to be tested differently, and you have diverged management, each one, because each language requires different strategies, different system to manage what you've implemented. And then 2, there's how you arrive at the math, that diverges. And so each implementation, think about this carefully, each implementation that you add nearly squares the complexity of the original implementation. And all you want to do is add a 2. And I haven't even mentioned the worst one, which is abstractions. Abstractions take away our understanding of what we're trying to actually get at, the math, right? It makes it really hard to understand. And that's why we're so afraid of it. Like we talk about, you don't want to have to worry about this underlying math, because if you do, you'll go nuts. There's so much to think about, because there's so many different levels of abstractions, and it all slows innovation. So our elegant and simple Atom 2, which you can see on YouTube, it's not really on YouTube, I made all that up. It doesn't stay elegant and simple, even though in theory, in the math it doesn't stay that way. And so we have to kind of change our understanding of things if we want to scale, right? And our elegant and our simple, our engineering, right? What was the main objective we want to get at? Innovation. We want it to be innovative. We want to be more innovative than we currently are. So Frank Zappa, he mentioned this, without deviation from the norm, progress is not possible. He's kind of a interesting fellow, but what he said was absolutely on par. Without thinking about things differently, we're going to just keep going down this road of divergence, and it becomes more and more difficult as time goes on. So I'm going to change pace here a little bit. There's this movie I watched recently with my kids, and I loved it. It's such a great movie. I won't spoil anything for you in it if you haven't seen it, but Big Hero 6. Now, in it, there's this fantastic illustration. Hero, the main character, he builds a robot. And that robot it's really cool. It's extremely capable of doing all these kinds of really gnarly things. And he sets his mind to innovate, to do something even more amazing than he's ever done before. And all he does is simplify the design and make it smaller and more portable. And when he presents it to everyone, nobody's head even turns. Like, it's not even that big of a deal. And then he shows what they're capable of by simplifying, by innovating. By using this little bitty bot, he basically turns into a superhero. And everybody, they turn and they look at him and they're like, what? You know, he's like floating from the ceiling and he's skating through the air because these little bots are aiding him, because they're simple, because they're innovative. And all he did was make it simpler. So there's a really amazing story to be expounded upon there. So if we were to kind of take some of that away from Big Hero 6, of all things, what if we did something more radical? Implement it once. And I mean truly once. Now, think about that for a second. Implement it once. There's currently being planned, right, by very large machine learning players, huge entities out there that run the biggest search engines on the planet. They run my phone, right? They say, we're going to do it. We're going to implement it once. So let's walk down that path, what they're talking about. They implement a new language right at the start. Brand new language. Yay, right? Amazing. So now you don't have, 8 languages or 6 or 5 languages or 3, you've got 2 languages, but you still have bindings and you have a new language. Now think about that. We have a new language. Guys, we do not need another language, and we do not need to implement it twice. These are not, we don't need to do that. We've had for 30, 40, 50 years low-level math being handled on hardware. And we have a means of describing that in higher level languages, such as, for us, JavaScript or Python or whatever the case may be. We have a means of describing how to perform the math. The problem is we don't have a means of talking directly to those hardware devices, or at least we haven't. And this implement it, they quote once, but really it's twice. It still leads to abstractions. So that's still a problem. So we have to reboot our way of thinking if we really want to get down to the metal and think of things and implement them once. Now, I got started in machine learning. I did a lot of research prior, but what really kind of sparked it for me was when I was looking at the internals of Brain.js. Brain.js is a really nice JavaScript library, and it's written in JavaScript, and it is, at the time it was written just for the CPU. Now it runs on both. But they did everything in one language. And their backpropagation used 2 forms of training rather than just one. So 2 optimizers, 2 trainers, whatever you want to call it. We call them Praxis in Brain. And to me, that was super innovative. I'd never seen anybody do that before. Backpropagating using 2 different forms of training. And I actually went ahead and named it the Arthur deviation because it deserved more credit than it was given. In fact, this fellow here, Jesus Siajes, I think is his name. I probably am pronouncing that incorrectly. He went on and he took Brain and he turned it into a natural language processor. And his quote from this URL, "We broke all the records." And he was comparing Brain.js, this little meek little library, to Google Diagflow, Microsoft Luis, and IBM Watson. He outperformed those with this little bitty, and I think in part is because of the quick, innovative ability to edit in one language. And that, for me, that turned Brain.js into a superhero. That was amazing. So if we were to truly implement it once, we run into some difficulties here. The type inference, transpiling, error handling, type handling, language differences, because you have multiple languages to kind of translate into, but we really don't have time to expound on that because I'm building my argument and I'm over half my time has been ate up. So we're going to skip that. But we're going to just tell you right now that GPU.js translates to GPU code for JavaScript. And right now it does it for both Node and the browser. And Brain.js is written in JavaScript, and it's currently being converted to TypeScript. It implements GPU.js. So I'm not just here to plug Brain.js and GPU.js. I'm really here talking about the principle. I just want to make sure I convey that. The idea is to write it once. Bugs are handled once. There's no divergence. You embrace the math, because the math, when we write out the math for these operations, the math is beautiful. But as soon as we engineer it, we take all that beauty away. But I'm saying let's embrace it and get as close to that as possible and let that be a commanding force. By doing that, you keep your sanity and you innovate faster. You become like a superhero. You think about some superheroes that really set them apart, the guys that were normal, like Batman. It was the car or the suit, right? It made him a superhero. It was something, I mean, you could not, maybe it wasn't very simple, but the car, for Big Hero 6, it was that little bot. So here's some practical examples to convey, I guess, kind of what I mean. So our first example was written by Gant Laborde, and he wrote colorblind, what it's like to be colorblind in TensorFlow. And so this was the TensorFlow version. I call this the canned approach. Okay, so we've got like these functions that we get, and there's nothing wrong with those functions. In fact, in parts of Brain.js, we use those functions just the same. But just bear with me. You have to, with TensorFlow.js, you'd have to to alter any one of those methods like split, mean, stack, or concat. You'd have to be able to get at the code, the underlying code, and for each of the environments. So that's really what I'm talking about here. So that's the canned approach. Now this is the, I've got Brain.js up here. That's actually the GPU.js version. So we set up our environment. You see settings. We have our output width and height, and that we're graphical. But really, everything that is important is in the create kernel function. So we're grabbing a pixel, and we're just basically dialing in what the red-green average is, and then setting our color. So there's really like 3 lines of operations there. And that is, for me, the direct approach, because you're dealing directly with the numbers. And for me, that's more innovative. So that's one version. Next one is a green screen. We took that baboon. I didn't even show off that picture of the baboon right there, the top right. That's what it looks like, the output, right? So it's kind of like, well, there's some color missing. That's because that's what it looks like when you're colorblind. The green screen, I took that baboon. I took a green screen from Wikipedia, and I merged them together, just thinking, hey, what would that look like? And so this is the math behind that. So you basically just take the color difference, and you're just saying, hey, should I replace because they're within a max difference or min difference? I've gotten this one before, the Mandelbrot set. A lot of people look at that and they see the math, and it's so simple, and then they're like, what? I can't understand it. It's too complex. Well, this is the Mandelbrot set. Beautiful. And somebody even wrote a Mandelbald for GPU.js. This is the code that actually is the Mandelbrot set. Just we run it recurrently, or in a loop. So it just kind of compounds on itself. But that's what it looks like in JavaScript, right at the math. And here's a more practical example in Brain.js. So in machine learning, there are layers, and there are forward propagation and back propagation. Well, just taking this one layer, which is the add layer, and we look at the predict or forward propagate function, we can see there's really one line of code aside from setting up the actual function name and the arguments. We have a return of the input weights 1, we get the x and y value, and then input weights 2, x and y value, and add them together. So it's super, super simple. Now, is there an end-to-end solution? So that's a kind of much bigger, right? Because we're talking GPUs all across the board. Well, I'm working on Welton. I'll have it finished maybe today or tomorrow, and links to it, that you can actually pick how you want a beer to taste and smell, and how alcoholic you'd like it. And it will tell you what type of beer that you're trying to brew, what color it will be, and even how to brew it. And it's actually not that hard. It's actually a standard classification problem. It's just we haven't really thought about the normalization, denormalization of the values. And but I'll have links to that on the presentation. And as a more general use, we have a practical example end-to-end for Brain.js. This is just XOR or XOR, or however you want to say it. The most important thing here is that the net is built on this new architecture called feed-forward, which relies almost entirely on the graphics processor. You can switch it, I say almost entirely, you can switch it between the CPU and the GPU. But here you sort of work with layers like you would with React components, if you guys are familiar with, setting up websites and that type of thing. So if you can think of Brain sort of being like the React for machine learning, we have an input layer defined as an input, hidden layers as an array, and the input from the argument previous, which is the actual layer instantiated, is going to be fed in. So these feed in recurrently from one to the next. You can have as many hidden layers as you like. Each return value from one is going to be the input into the next, and you have your output layer. And then it goes to the output. And then you basically net.train, net.run, and out comes some values. So that's not only just the end-to-end, that's the entire training, that's the entire running, that's everything. All the layers and maximum terse readability right there for you. So that's kind of like the proof behind this idea. And ultimately, we just want to make sure that, you know, we're trying to make something that's super straightforward, not just in engineering, but all the way down to the math. So the evolution revolution, that's the name of the talk that I've got today. And we're not talking about like evolution with animals or anything like that. We're talking about evolution of ideas. One idea builds on another idea, builds on another. For the longest time, all we have done is abstract into these separate layers. It's been very hard to do it the other way, which is to read the high level language and compose the lower level language. Well, that's what I'm proposing. And I've actually found out after you understand the environment, and it's really not that complex. In fact, everything is strongly typed when you're right at that layer, right at the execution layer, because you can detect what's coming in and you know what's going out and you're detecting where it's going. And so if I can simplify it, the high level language becomes the chalkboard. The Atom 2 implementation that we originally talked about becomes super simple, super elegant, because the IDE that you implement it on is exactly where you're testing it. And you no longer have to worry about those underlying languages because they're composed for you. So you write your innovation once. You embrace the math, and that leading on that previous innovation, that even leads to faster innovation. So that makes you like a superhero. That's my talk. I want to thank these guys, Clawhammer Supply, in addition, our MLConf EU and Clawhammer Supply for the beer recipes. Gant Laborde, I mentioned him briefly. He's been a really nice colleague in driving machine learning and understanding of it. And as well, the contributors to GPU.js, Brain.js, and then the SlideGo for these slides. Thanks, and hope you guys enjoy the conference.
Thank you again, Robert, for this amazing evolution revolution talk. It was really interesting perspective, right? Because usually we're thinking about machine learning only from mathematical point of view, and this brought a bit of also production and engineering point of view. So this is also helpful, right? Diversity does help make our products better. But before we jump into questions with Robert, we have like another question for you from Menti, so we can coach your audience, right, and your answers. Yeah, so in order to answer this question, please open your browser again. You know the drill, right? Open menti.com, enter the code 7196411. You can still see this code on the screen, and I will repeat it one more time for you. 7196411. And the question for this slot for us is, what is your favorite brain power snack or drink? Because we're sitting in this conference stream for quite some hours already. So how do you re-energize yourself? Please answer it on Menti, and we're gonna get the answers just like in some 10 minutes, basically. With that, I'm happy to welcome our speaker.
Hey, how's it going?
Hey, it's going pretty good. I really did enjoy your talk. How is it going for you? Like, I see that you still got a bit of sun on your side.
Oh yeah, it's just a pleasure to be a part of the whole operation. You guys have really put together a tight set of sessions, I guess. I don't know.
Yeah, it's funny that we have speakers like all around the globe, right? And you never know what time is it right now, right? And it's good to see that you still have sun, because for me it's already like night. But let's jump to the questions. I've seen some questions already like on our Discord channel that people can ask it in ML Q&A. And one is like really open-ended, but I guess it's like still helpful to answer since you're like also part of a team of maintainers of Brain.js. So the person is basically asking like, hey, it sounds amazing, right? But do you want to copycat everything for neural networks training in JavaScript when we have powerful deep learning frameworks like TensorFlow, PyTorch in Python? What is innovation behind it? And by the way, how big is the audience? Like, who is using? Where is the edge for this one? So the question is like really open-ended, right? But if you can maybe slice a bit more on your developer audience, right? And why, let's say, there's a new grade, right? New graduate basically from university, and he or she has a choice between, TensorFlow or Brain.js, and like what they should decide, right? And how's this decision process going to look like?
Well, so TensorFlow is a very open-ended tool, right? It's very each time that you use it, you end up starting, connecting up everything layer by layer, input and output, and then explaining that and running it. Whereas Brain.js is not really designed that way. It's more designed to allow for those repeat steps to be done for you, and so you can kind of get quickly to what you want to do without thinking about it a ton. As far as re-implementing, languages change over time, and there's new languages that come out. WebGPU, for example, is something that's brand new, so it'll have to be re-implemented in there, no matter where we're talking about, at least for those that want to take advantage of the graphics processor and JavaScript. So there's work being done in TensorFlow to do that. We haven't yet started with Brain.js, but really all we have to do is change the underlying engine, GPU.js, and then all of a sudden Brain.js will just speak that. So it's more of the idea between a long-term and a short-term investment. Short-term investment is duplicate the code, and you're building up technical debt. Whereas long-term investment is write it once, and then create an engine that transpiles it to whatever environment that we need to run it in.
Yeah, no, and I completely agree with you, right? Because you can also ask like, hey, we had like C, right? So why do we need any programming languages, right? You just copy functionality from one place to another, right?
Yeah,
and,
really.
It is helpful, right? As long as we understand what is, how is it different, right? Because you know that Rust is like memory safe, right? You know that Golang is like good for tiny things, right? And I guess you still have your definition for Brain.js. Maybe, it's like very impromptu question, but how would you explain Brain.js like in one sentence, right? What is this, like Rust is like for memory safe, right? And Brain.js is like for...
Okay, well, I would say it's a practical machine learning library that is data centric. It works. Nice. It's really tailored to working with data first. And I don't know. There's a way to. I would clean that up probably.
Yeah.
I wouldn't broadcast it, to thousands of people, but.
Yeah. No, it's also a bit of like me asking it like on spot, right? So don't worry about having like super clean answer. And I guess like, what you said, practical, is something that sometimes we also forgetting, right? Because by you just using like out of the box, perfect, like working solution, right? You don't learn much, right? You cannot be creative, right? You cannot go extra mile and apply it in a different fashion, right? So it's definitely like a good USP, right? You just need to find what is a strong side around this one.
Yeah, so an example, we started working with convolutions, and there's parts of the network, parts of Brain.js, the project, not the network, where there's different networks that you can use, and in researching, for example, convolutions and actually looking at the shape of them, I found that they're really not well understood. You can look at, and there's an algorithm that's implemented, but actually seeing what it does is so much different than, or rather how it does it is so much different than the way that we have traditionally thought. And that's why you'll see these really like inefficient implementations of it, where they step through each cell and they basically just ask if something relates to it. Whereas the really quick way is to bend it the other way around, where you say from the output, look exactly up your inputs and then like calculate. But I found that there's not really any good examples for the back propagation of that, and it really bothered me. But anyway, we ended up writing it. After you see it though, like in JavaScript, in a language you don't understand, it's like a light bulb moment. Oh, it's so simple. You're just like looking up the locations, and it becomes a whole lot more digestible.
No, it's a good point. Like, I think it's like a good way to also, I mean, I don't want to say sell, right? Because you don't have to sell anybody. It's like open source product, but a good way to explain what is it about, right? So it's a good point. Maybe different type of question, right? I'm not sure if you did follow like for other bigger machine learning frameworks, right? But right now I have a feeling also that who is using framework in research, right? It's like a good indicator who's going to be like what people are going to follow later, right? Because like the more cutting edge research, right? The more pre-trained models, like the more exciting model zoo is like available for developers or engineers, right? The more easy they transition from, I don't know, to TensorFlow, to PyTorch, to Brain.js, whatever else. So the question, I guess, like going to be like in two parts. Like one part, do you feel or do you see like a community of researchers like trying to use Brain.js, right? Because it's like so easy for them to, you know, convey what they want to try to implement. And second part, do you try with maybe team of Brain.js try to make it easy for researchers, right? And do you feel that they're like also part of your audience, right? Or are you mostly focusing on developers and consumers, basically? How do you feel about this one?
Yeah, so I'll try to answer and try to remember the best I can. Are there teams of researchers that use it? Yes, there are. One project that I saw was the ability to look through a human body from different points of view. So you could actually pull out like meaning from those slides, but having it basically on the graphics processor, you can basically like process that data very easily. You can see it, and then you can, and actually we ended up using GPU.js for that too. But I think it's more about like, if you can see the results of something, if it can prove that it is a valid tool by numbers alone, and by the logic of it being simple, then it's a shoe-in for anybody to pick up. And one of the examples that I highlighted in my talk was that of natural language processing with Brain.js, where it actually beat Watson and like the biggest players, machine learning players of the time, because there was a bit of innovation that happened within the net, where you could use different types of activation, which is now something that you can do, but I hadn't seen it at the time. And then what was the latter part of your question? I didn't recall.
Yeah, do you try to explicitly target researchers, right? I don't know, like maybe some people are trying to build tools for them, right? Or trying to just engage what problems they're having, right? Because I guess what engineers who are using already, you know, like established models, right? And somebody who are trying to be flexible, right? Those are different needs, right? You need different kind of like APIs or whatever else, yeah.
No, not targeting anybody, just targeting simplicity and JavaScript. We don't have really mature tools yet in JavaScript outside of TensorFlow, and so that are really efficient, that really take advantage of the hardware of a computer. And so Brain.js is my selfish work to achieve that, basically for myself. Yeah.
And it's a cool hobby, right, as well, so I completely agree. And additionally, there is also like quite a bunch of JavaScript developers all around the globe, right? So for them, having one more tool is definitely something cool and exciting. If I would be a JavaScript developer, I would be definitely open my console and just be like, hey, let's do some Node.js. But for now, I'm more like on the Python side. So let's see how it's going to develop. Cool. It was awesome having you. Thank you again for your answers, for your open source contribution, and for your amazing talk.
Thank you very much. It was a pleasure.
Cool. And please give virtual applause to Robert also on Discord, because I mean, there is like a good way to see appreciation for one person. But if you have like a couple of hundreds like doing that on Discord, that's going to be like a big wave of appreciation and applause, obviously. If you remember, we started this conversation from another question from Menti as well. So the question was, what is your favorite brain power snack or drink? And let's see what are the answers. And it looks like 65% of you are coffee people. Interesting. Like, I think we should have had also tea here. I'm more like on the tea side, but let's figure out in the next one. The next one is Menti with his like amazing speakers.
Yeah, that's me, I guess. First, once again, I want to thank one of our sponsors, Focus Reactive. Focus Reactive is a London and, of course, remote-based consultancy offering expert-level JavaScript, React, and Node.js software development services and also coaching. So thanks a bunch, Focus Reactive. Now it's time for our next speaker, which is Shivani Podar. She is super active in the community. If you look her up on LinkedIn, you can see that she's sharing all sorts of amazing stuff on machine learning. She's an ex-Amazon Alexa Prize winner. And yeah, she seems like an amazing person. And I'm really looking forward to our Q&A session later on to get a bit of a chat going on. Besides being of course, machine learning developer, Shivani is also, I lost my train of thought. She loves to work out and paint. And if you're gonna invite her for dinner, she would love a Neapolitan pizza, which is her favorite, while you can watch the Netflix show The Queen's Gambit. That reminds me of the AlphaGo movie, like where the Google DeepMind beat the biggest chess players. That's amazing. Maybe something like that will come up in her talk. Let's see how it goes. Give it up for Shivani with some virtual claps in the community Discord channel.
Hi, everyone. I'm Shivani. I work as an ML engineer at Facebook. And today I'm going to share with you how to MLify almost any product. This talk is going to be a more practical talk where I'm going to walk you through when is it okay to use ML. We are going to discuss a use case wherein I at Facebook used ML and successfully so, and I'm going to walk you through the cycle of an ML model's development. Cool. So the first question that we have to answer is that, is your product really ready for ML? So this is one of the biggest mistakes that people do, is thinking that anything can be plugged in with ML and any problem can be solved with ML. So I think really there are two questions that you want to answer. The first one is that, can your problem be solved with simple rules? Can you just think of a threshold, or is it a binary flip decision of whether or not your problem can be solved with a simple rule? The second one to think about is, what is the scale of your problem? Do you need to generalize your solution to a lot more people than a few hundreds? One example is that, say I want to classify apples from oranges and all of my product is just about classifying apples to oranges. Having a small filter which would say orange is orange and red is apple would be a reasonable approach if I have 20 users who are using my product, and not yet justifying whether or not we need ML. However, if I was to classify different types of oranges, which could also be reddish, and different types of apples, which could also be orange, I would need more than just color as a rule. I would probably need the shape. I would probably want to employ some computer vision techniques and so on. And so if you can answer both these questions in affirmative, that you do need more than just simple rules and your problem is ready to scale, you need ML for your product. Let's now walk through a real life scenario of how we use this for Facebook portal. So I was working in the Facebook portal team, and one of our hero features was calling. So the user would come, they would say, hey, portal, call John. And the idea would be for the device to understand who John is in your friend list. And if there's multiple Johns, then it should disambiguate who the right John is and then create a call to whoever this person is. And note here that the the cost of failing is high because you're ending up calling the wrong person, you leave a missed call. And so really the option here is to be very precise. And so when we started out, the flow we had was that the user would initiate this command, Portal would understand who the most possible John is. And this was simply rule-based. We would pick the top contact that we got, and then we would issue a confirmation prompt. And so if a user said, yes, I confirm, call them, we would call them. Otherwise, we wouldn't. But this was a very tacky, long process, right? The user had to come in and select confirm, select who they were calling, oftentimes engage in touch in the UI, and would just take away from this experience of the user interacting hands-free with this device, which is smart. And so we had to tackle this problem of, hey, given John, how can I predict who the actual John is so that the user does not have to come in and do all of this work themselves? And so there are a lot of rules that we could have used. We could see the similarity score in whether the name reflected or matched the name of the person. We could use confidence score, whether the ASR confidence, and ASR is a speech recognition system, and so whether it understood John correctly. We could also use the relationship of the user to the person they were calling. So naturally, if somebody was a family, they would be more likely to call for some users. And for some other users, if someone was calling a John they messaged or called frequently, it would be more likely that they're calling the same John. And then it could also vary on time of day, whether they actually gave the command or not. So for a lot of users, they would be talking to somebody else. Sometimes ASR picks up incorrectly whether or not the user is trying to call this person. And so what is the probability of noise? What is the frequency in which that they're talking to this one person? What is the score of all of these upstream modules that essentially translate any speech to text? And so all of these were a array of rules, right? And they could not be abstracted in one single rule for our purposes. And so since these are not just one rule, and we needed the model to actually learn not just from a single flip-flop rule, but a data distribution, we decided that we're going to be leveraging ML for this problem. And so this is the problem I'm going to walk you through this life cycle of the ML model development. This is what it looks like, right? So whenever you've now decided, you've answered this question for your product that you do need ML for your model development. And so what does it look like? It starts from data collection. Data collection is setting up the right feature and label sets for your model training. And so this can be organic, or this can be artificial. In our case, for the example I just gave you, since we were already using confirmation prompts from the users to decide whether or not the contact was the right contact, we already had organic labels collected for our features to solve this ML problem. And so one can either use the pre-ML era data, which is anonymized from their pre-existing user interactions to train their model, or what ends up happening in a scenario, you can actually create tools to collect data to solve the problems that you're after. For the purposes of this talk, we are going to be focusing on organic data collection and how can you get data from an already pre-existing product, and how can you then use that data to inject ML in your product. And so this is what our features look like. For our organic data collection, our features were ASR confidence score, which was if a user says something, our ASR or speech recognition engine translates that to text, converts a converts it into text and generates a confidence score with it. We then have the NLU engine, or the intent detection engine, that takes as input this text and outputs the intent of the user. So the user could have wanted to create a call, they could have wanted to message, and so on. We then have the entity recognition engine, which takes the name of the user's friend here, John, and then predicts who the actual contact is. And so this is entity recognition, which is contact recognition. Once we have these, we also have some other user context. So how often does the user message this person or call this person? This would give us context to know whether or not this is a new contact that the user has never messaged, or this is somebody that the user oftentimes messages. Once we have these features, we then also curate labels from that confirmation prompt, where if a user said yes to the confirmation prompt in our previous log data and ended up creating a call to this contact, we say that the label is a positive label. If not, and if the user said no or cut the call right as it dialed, we say that it is a negative label. So now that we have our data set up, the next step is, how do we decide what ML model to use? How do we decide whether to do neural networks, deep learning, or to stick with the simpler classical ML models, use just regression or decision trees, and so on? So for this purpose, we knew that we wanted to learn nonlinear transformations. We had a lot of rules, and we wanted a model to be able to learn complex planes in those rules. We also knew that we have a mix of categorical features and discrete features, and also data distributions. We knew that our categorical features could be sparse. There could be some information available for some users, while some users might not have given information like whether somebody's their friend or family, and so on. And so given these aspects, and given the fact that we wanted to use as little compute as possible, we decided to use GBDT. GBDT are gradient boost decision trees. These are most simplistically an ensemble of regression trees that are averaged together to perform a classification task. So it basically iteratively learns which features to inject at each of these nodes to output the leaf label, which is whether the so some way in which this will look like is with the previously discussed rules. The model will learn whether is a user a family or not, and then based on some threshold that the model has learned, go to one leaf or the other. In the next decision, it could learn whether or not the user called this friend in the last 7 days or not. And then again, based on the threshold that it learned, it can go to the left-hand side or the right-hand side, and eventually predict the label learned by the model in saying that whether or not this is the right contact. So this was the model we used. And now that we have the data, we had the model, the next step is evaluation. How do we evaluate, or how do we understand that the model that we used actually performed well? How do we train the model, and what metrics do we use is the next question. So there are two kinds of evaluation that I'm going to cover. One is offline model evaluation, and the second is online. Offline model evaluation is purely done at the development time. So you do a quantitative evaluation, which is focusing on quantitative metrics, and you do qualitative evaluation, which is focusing on actually how the data looks like. So for quantitative metrics, an array of metrics can be used. It could be precision, recall, F-score. It could be accuracy. These are for more classification kind of tasks. For more natural language generation tasks, one can use BLEU scores. For more similarity detection tasks, one can use similarity scores. And so this depends on which model you use. For our purposes, we used quantitative metrics of precision recall. And we also use qualitative analysis. So qualitative analysis is very important at development time. So, and here's why. Your quantitative metrics will tell you whether the precision or recall of the model is great. However, what if all the labels that you had were ones? So all of your data set, you had 20 samples and all of your data set was one single label. The model will very easily learn that I always have to predict one to do well on this data set. And then when you actually test the model on more data, which has other labels, the model might start predicting those wrong, will start predicting those wrong. But in your test data set, this label that you had in abundance is, say, 80%. And this new label that the model has never seen before is, say, 20%. Your accuracy still stays 80%. And so unless you went in and qualitatively analyzed how your model is doing and what it's predicting, you would say your accuracy is 80%, which is great quantitatively, but does not scale well qualitatively. And so for our purposes, we did both quantitative and qualitative analysis. Our model did really well, and we were able to get a high precision of over 95%. And qualitatively, our model seemed to do exactly what we wanted it to do. Another point here is that for our purposes, precision was one of the most important metrics. And here is why. I've alluded to this point before, but if we made a call to the wrong person, and now remember, we've gotten rid of that confirmation prompt. And so if we made a call to the wrong person, that would mean that the user would have called somebody they didn't mean to, and would have like this embarrassing situation ahead where they would have to explain how their smart device was not so smart anymore and ended up calling this person. And so what we had to do and optimize for was reducing our recall even to the point where precision tended to almost 100%. And so a lot of times the thresholding that you select for your model would depend on your end use case. And you might have to make trade-offs where precision recall is a curve. And so you might have to reduce your recall to improve your precision, or vice versa. There might be other scenarios in which you want to fetch the maximum kind of things that you can, increase recall, while you might have a leeway to decrease precision. And so, great. So now we have data is collected, model is modeled, offline metrics look good. What's next? Next is online evaluation. So now that we are confident that our model is doing well, we are ready for deployment. How do we know? How do we productionize this model? How do we know that it's actually working well for real users? Do we just launch it to everybody? So no, we don't. We have a second step before we can do that. So for our purposes, we productionize the model. We write a wrapper which essentially abstracts the model binary and makes it available in runtime with a predict function where we can derive the features that the model learned in real time. So now that we have a request, the user made a request, we featurize that request into all of those features that we discussed before. And we call this predict function in runtime with these features. We return a label, and then in runtime, we see whether or not the user actually ended up creating that call or went in and canceled that call. And so that's when we come to online evaluation. And we develop these proxy user-facing metrics. So these metrics can be something like call success rate is increasing, and call success rate is defined as the call that the user initiated and then ended up completing and not just dropping off. And then we can also define anti-metrics. For example, call cancels are increasing is an anti-metric. We don't want that to happen. And then we essentially roll it out to a set of users, a smaller set of users initially. We call this A/B testing. we see how these metrics are trending. And if these metrics are trending as we expected them to trend, then we go ahead and launch the model to a larger group of people, and so on and so out, and do a progressive rollout until we've launched it to everybody. If not, we go back to the drawing board. We see what the issue is. We see whether it's hyperparameter tuning that we need to change, and so on, to figure out exactly where the model is not performing well. Finally, one would think that you've done data collection, you've done ML modeling, you've done offline evaluation, you deployed it, you did stellar online evaluation. What next? There's one more step which people oftentimes miss, which is active learning or iterative learning or maintenance of the model. So what is active learning? Active learning can be, in this context, it means a lot of things, but in this context, this is purely from the standpoint of how will the model maintain its online metrics over time, over different users, and so on. So we only, in active learning, we will trigger retraining of the model when either the upstream modules change. So in our case, we had NLU module, which was detecting intent. We had ASR module, which was converting speech to text. And we were depending on the confidences from these modules as features. So what if my NLU model changed and the meaning of its confidence changed? What if the confidence that it was predicting as 0.5 before was 0.6 now? My model will start making wrong predictions if it was still in the older distribution while the distribution from the newer model changed. So if any of the upstream models which inform the features of the models downstream or your model change, you need to trigger retraining. If there is a change in significant number of users, so oftentimes there will be different patterns that the model learns based on the current users that it is learning on. So if there is a change in those, then you will have to retrain your model. And then lastly, if you explicitly evolve your features, right, based on qualitative analysis. So you realize that there's more features that you can induce in the model to make it better, make the recall better, precision better. You, of course, need to retrain the model. And yeah, so all of these together will ensure that you have a robust ML model at the end of the day for your users, and will ensure that your model is adapting itself to the changing infrastructure as well as user needs. Thank you. I hope that you learned a little bit about the ML development cycle in a product company like mine, and reach out for any questions that you might have, or if you'd like to connect.
Whoa, that was mind-blowing. As you may remember, what I said in the introduction, I'm a front-end developer, and I think there are 4 words which I understand. I'm usually just trying to move boxes around and trying to make a website look good on a mobile phone, and this is mind-blowing stuff for me. So thanks, Shivani, for sharing your knowledge with us. Before we're going to introduce Shivani to our Q&A session, we will go to another poll. So please get your phone or another browser tab or whatever you use to go to menti.com and enter the code 5478871 and answer a question. How experienced are you in machine learning? So you'll see the possible answers there. So once again, go to menti.com, enter the code 5478871 and submit your reply. And now I would like to ask Shivani to join me here on stage.
Hey.
Hey,
thanks,
good
Matt.
to have you. Thanks for joining us all the way from the States. It's a bit early for you, probably. I hope you have some breakfast.
It's 9:30 a.m. It's not that early.
Good. You didn't have to set your alarm for this. Nice. we're going to go to the first question, which is from our audience member, Sanjit. And he's asking, how is your AI methodology different than any standards like SEMA/CRIPS-DM methodology?
I have no idea what the acronyms meant. Maybe if you can say them again, I'll know better.
Okay, Sanjit, if you can explain further, then we'll try to get back to your question later on. We'll go to the next question, which is from Kent.ano. At the start of your talk, you said the problem had to be solvable with simple rules. How to tell if this is true? Do you sometimes just go, probably, train the model and check if it solves the problem, even though you're not sure what the rules are?
Yeah, I think that's a great question. And you're right. Not always can you blatantly tell whether a problem can be solved with simple rules or not. There's two general categories of problems that you have. One is classification problems, and the second is generation problems. Classification problems mean that you have a data set and you want to basically classify it into labels. And it sounds simple, but this can have an array and gamut of ramifications or applications in the way that it's used. Generation problems say that the machine is given a data set and it has to come up with its own way of generating something. So these cool things that you see where a machine is writing poetry or a machine is writing stories, all of those are generation problems. While when you see that a machine can detect objects like apples from oranges, those are classification problems. So oftentimes you will see that classification problems are the ones that can be solved with simpler rules, while generation problems are more the ones where you want to rely on just any ML algorithm and then go from there. And so that's usually my go-to mantra for deciding whether a problem is just solvable by rules or with ML or not. But this is basically what I use.
Mm-hmm. Okay. Well, I hope that Kent Ano is happy with that answer. Just as a reminder, there's a discussion room going on about computer vision on spatial chat. So be sure to go there after we've done this Q&A. The next question is from my co-MC, AJ. You mentioned about gradient boost decision trees, which is definitely good, but isn't gradient boosting slow for practical applications? Would an algorithm like cat boost or XGBoost be better in general?
So I guess from the perspective of any company, like whenever you're building machine learning at a big company, you ideally want to rely on algorithms which are tried and tested, especially when you have the scale of people that you're deploying that model to, as we do. We have billions of people who use our models. And so to that end, a lot of times, yes, a bunch of these alternate methodologies can be better on paper, but we like to default to the ones that have proven better in practicality or once we've deployed it. And so we always have to see whether a model scales well or whether a model is able to be good around edge cases and gradient boost decision trees from both qualitative and quantitative analysis over time, at least from the perspective of the work that I do, has been established to be one of the best approaches. Having said that, that is not the only approach. We could have used any other approach and gone through the same cycle that I illustrated there. And we would have had gradient boost decision trees not performed as it did, which was beating the expectations we had from the model. We would have gone back to the drawing board and tried for looking at a different model.
Okay, thank you. We have another question from an audience member, Minhai. What was your hardest challenge while working at Facebook?
Ooh, that's a good one. That's a great question.
There's enough challenges there, right?
No, I think I really like working at Facebook. And I think that this is one company which is bottom driven as opposed to top down. Every day we decide what is it that we are excited to build, and then we roadmap what we are building. And The only thing we have to see is whether that aligns with the goal that the team and the company is going in. And so to that end, it's a lot of freedom to actually build things you really care about. But then because of the scale of Facebook, it's also a lot of responsibility. So when I was at grad school many years ago, I would just take any model I liked, take any data I like, and throw in the model and try to publish a paper without thinking about whether this data is anonymized properly, whether I'm protecting user privacy and whatnot. Mm-hmm. So now I think since we've learned so much, everything I have to do at Facebook has to be considering all of these things and the ramifications before I just go and build a model and just deploy it. So I think all of the good guardrails that we have in place to ensure that we protect the data we are using for machine learning appropriately, that and how do you make a model work, which depends on this data, and balancing those has been one of the most challenging and exciting things to learn, because now there's things like federated learning, which tell you how can you actually featureize data on client and then send it to the server so that you don't compromise any information that the user doesn't want to share and whatnot. So it's a lot to learn, but I think it's both challenging and exciting.
All right. So as I understand, it's more about working at the scale of Facebook than actual technical challenge you have. And
yes.
the data protecting privacy and stuff. Yeah. Well, good to hear that that's high on the agenda. Next question from our audience member, Rag. How is GBDT different from reinforcement learning?
Yeah, GBDT is, so reinforcement learning is more, it's defined very differently in terms of just the way the problem is mathematically represented. Where in reinforcement learning, you basically have a reward function you define, and then you basically try to make sure that every action, and you learn a policy, that every policy a user takes can optimize that reward function. And so, or a user takes or a machine takes can optimize that reward function. GBDT, while this problem that we are tackling, it's great that you asked this question, can be very well modeled in reinforcement learning, because to decide whether or not we call this contact or not is deciding a policy or an action for the assistant in this case. We haven't yet used reinforcement learning to model it that way. And we use GBDT, which is predefined labels. We don't have a reward structure defined, which we try to maximize here, while in reinforcement learning, you would have the whole reward function. You would probably do Q learning, one of the reinforcement learning algorithms to optimize the same problem. I hope that answers your question. I'd have to go in a whole spiel. I'll have to go in a whole spiel and a lecture about deep learning, reinforcement learning, if I go any deeper.
Well, that's what we're here for today, right? But let's not forget, after this Q&A session, you're going to be in your spatial chat room, right? So people that have more questions or want to go even deeper on your answer, they can go there and discuss further with you. One more question from our audience member, Ansal. How do you handle label delay? An example, labels arriving 1 month later than the training data.
Great question. Label delay, I think I would presume that how do you handle any delay of features or data coming in? There's multiple ways to make up for things like label delay. One could be a data augmentation approach, where you say, this is what I hypothesize, or computing your expected labels and basically training your model from there. And once you do have the labels that you're waiting for, then doing the self-learning or active learning thing that I mentioned, which is anytime your labels change, you trigger a retraining of the model. In this case, you will compromise the performance of the model for the initial whatever time you have the expected labels. The performance will be suboptimal. However, this will ensure that you have an independent and self-learning pipeline of modeling developed. But I'll have to understand more about what this label delay looks like to give a better answer, which might be more suited to this particular use case.
then once again, we'll plug your speaker room where people can ask more questions or go deeper into your deeper into this answer. So Ansel, if you want to discuss with, I'm really lost for words today. It's a good day to be an MC when you're lost. So if you want to go deeper, go to the speaker room. And right now, I just want to thank you for joining us, and I bid you farewell to your speaker room.
Thank you.
Okay, bye-bye. So as you may remember from the start, we wanted to see some photos of how you are watching this conference. So show me where you are, show me your home office, show me the beach you're at, show me the top of the mountain where you're with your phone on the 4G connection, maybe 5G even. Show me where you're watching. Tweet with the hashtag MLConf EU. Show us where you are. It will be fun for us to see. And of course, we have the nice raffle where you can win the Git Nation Multipass. So next up is a break. We have another 10-minute break. But before that, we're going to go to the results of the poll. So everyone has voted. And how experienced are you in machine learning? Well, most of you, 48%, are starting their machine learning quest. So it's good to see that people are here trying to learn more stuff. So I'm really happy. And 32 even is a student. So there's only 19% that's expert level. So really happy also, of course, to have the experts here that they can help the students and the starters in their machine learning journey. So fun to see this. Okay, so now it's back to break time. Hope to see you after the break in 10 minutes. And after the break, we'll have the next speaker, which is Lawrence Moroney. Really looking forward to his talk. Bye, everyone. See you in 10.
Fill me out with your smile. Now the sunshine brings the light.
And we're back, everyone. Hope you guys have you all had like a wonderful break. You went to the restroom, you got a nice snack, you got a little beer, whatever it is. Hope you did well. Now, before moving on to our next speaker, let's just quickly mention our silver sponsors, MathWorks and Infinite Red Academy. Once again, this conference would not be possible without them, so thanks a ton. Alrighty, now on to our main speaker for now. We have Mr. Lawrence Moroney. So let's start to get to know about him a bit. So he's a bestseller author of many tech books, a script writer for quite a few sci-fi scenes, an instructor on Coursera and YouTube, an AI advocate of Google, an artist, and I don't even think I got even half of like what he's done. Now, one of his major goals is to spread the knowledge of TensorFlow and how we can leverage this for machine learning. His time at Google was quite the adventure. So he started out on Google Cloud and then moved into mobile development, working with Android and Firebase. And he also dabbled a little bit in the making of maps. And in 2018, he moved on to TensorFlow. So a couple of fun facts. Fun fact one, his intrigue in machine learning started during his graduate degree when he created a tic-tac-toe learning algorithm that would learn from past mistakes against humans. Fun fact number two, he's hosted a series on Google developers, that YouTube channel, which is called Coffee with Googler. So if you want to see a certain Googler drink generous amount of coffee while spouting knowledge on tech, you totally know where to go. And fun fact number three, he's also really good with CGI art. Like, I mean, really good. You need to check out his website for some more cool art. And with that brief intro out of the way, I'll pass the mic on to you, Mr. Lawrence Moroney, and you can get us started. But before that, let's greet him with some virtual applause in the community channel on Discord. Woo! Yep.
Hi, everybody. I'm Lawrence Moroney, and I lead AI advocacy here at Google. And it's really my job to educate the world around AI and to try and make the world a better place through AI. A little bit about me is I'm also the author of this book, AI and Machine Learning for Coders. It was just released, so it's quite a new release, and it was actually the #1 bestseller in a number of AI categories in its week of release on Amazon. And if you're interested in the book on Amazon, this is the URL. And the book itself is actually based very much on the syllabus that I'm going to be talking about during this talk. So first of all, I want to talk a little bit about AI and where AI is at. And this curve I like to use, and this is the Gartner's life cycle curve. And the life cycle curve of any technology usually begins with the technology being introduced, and then it reaches this peak of inflated expectations. And the peak of inflated expectations is the kind of thing that when you see massive hype around the technology, but that hype isn't really based around anything real on the technology. It's based around speculation on the technology itself. And then often the life cycle curve drops us into the trough of disillusionment. And despite the negative sounding name, it's actually a very positive thing, because that's when we blow through the inflated expectations, we blow through the hype, and we understand what the product and what the technology is really all about. And then once we reach that point, from there on, we can reach productivity. Now, unfortunately, AI right now is probably somewhere about here on the curve. There's still many inflated expectations. And just to call this out, sometimes those inflated expectations can be positive, where everybody's thinking about like the amazing things that can be done with the technology. And sometimes they can be negative, where people are terrified and they're afraid of the technology, but their expectations about its capabilities are what are inflated because of this hype cycle curve. But my job is generally, I'm trying to get people down here into the trough of disillusionment. And I sometimes joke that I'm a professional disillusioner, but really with the idea of having the world understand what AI really is all about, what you can do with AI, how you can build with AI. And from there, then you can grow up into the productivity. So like I said, we're here right now. And my question then becomes, why do you think we're here right now? Well, there's a number of reasons behind this. The first one I will show is this number. And this number is 300,000. And 300,000 is the number of AI practitioners in the world, according to a survey done by a company in China. And so they wanted to just take a look at why is there such a global skills shortage around AI? This was about 2.5 years ago. Why was there such a global skills shortage around them? And they wanted to say, well, how many qualified people are out there? And it was 300,000 AI practitioners. Now, I like to compare this with this number, which is 30 million. And there are a number of estimates out there as to the number of software developers globally. And they vary wildly. I've seen some around 22 million. I've seen some around 35 million. I'm just picking a number roughly in the middle of that, and it was 30 million. And I could argue actually that the number is far greater than this. So for example, at WWDC this year, Tim Cook mentioned that there are 28 million developers in the Apple ecosystem alone. So if I did a rule of thumb that half of the developers in the world are in the Apple ecosystem, we could be actually closer to 60 million developers globally. But let's work with this number of 30 million. Now remember, there are 300,000 AI practitioners according to the survey. There are 30 million software developers according to my estimate. So I made it our vision at Google as what if we could train 10% of the world's developers to be effective in machine learning and in artificial intelligence? And if we did that, we'd have 3 million AI and ML developers, which is 10 times this number. So we made that our goal. Can we increase the number of AI practitioners globally by 10, by a factor of 10, not by a number of 10? So, we said we'd set down, we'd make this our goal. We started this journey about 18 months ago, a little over 18 months ago. And today I just want to share the strategies that we used and the results that we've gotten. But first of all, when working with software developers and when I talk with them and when I would look at how they were being trained, I got a lot of feedback around why they thought AI was difficult and why AI was something that was, while it was something that was of interest to them, it was something that it was going to be too difficult for them to kind of give up a lot of their time and a lot of their study time to be able to pick it up. And I started seeing a lot of terminology, like I've put in this chart here, people saying it was difficult. There was a lot of math. There were a lot of terms that they weren't familiar with, like unsupervised learning or supervised learning. They really, like me, they hadn't done things like calculus and probability in 25 years. And as a result, the number of concepts that were being thrown at them just to get started made it like there was a massive road bump that you'd have to get across to be able to get started, to be able to transform your career and transform your skill set to be a machine learning or an AI developer. So I saw that as a challenge. And one of the things that we do at Google is that we give ourselves a mission, and our mission is defined by 3 words. And so the 3 words that I used were make AI easy. And so I've made that my mission at Google is really, it's all about making AI easy. And I skipped one slide here for a moment. And then that led me to this overall mission that I wanted to be able to train millions of developers to reach billions of people. And going back to the life cycle curve and the hype cycle curve that I spoke about earlier on, if we can train millions of developers, and I think millions of developers are the key to be able to reaching billions of people with AI solutions and with AI applications, that will burst us through the bubble. That will burst us through the hype bubble so that we can see what's real in AI. So we'll make AI easy. So some of the strategy around this was that the first goal was to come up with a syllabus of material and a set of content that was aimed at developers. So it was by a developer, me, and it was aimed at developers who are coders. You don't need a PhD, didn't need math, any of these kind of things. I don't have a PhD. And like I mentioned before, I haven't done calculus and probability and statistics in 25 years. So I wanted to come up with a syllabus that was by a coder and it was for coders. And then to build a strategy around this syllabus. And the strategy is twofold. First of all is the professional strategy. So this is the strategy aimed at educating people who are already developers, people already in careers as coders. And folks in that domain tend to be reached in 3 different ways. There's massively online open courses or MOOCs. There's being able to do it direct and at scale. And then there's managed training. So let me talk a little bit about each of these. So MOOCs, we partnered with deeplearning.ai and Andrew Ang and the great folks at deeplearning.ai to produce 3 specializations. We've released 2 of them, TensorFlow in Practice and TensorFlow Data and Deployment. And I'm currently hard at work on the 3rd one, which is going to be released in November and December. And we're calling that TensorFlow from Basics to Mastery. And the idea behind this one was to produce 12 courses in 3 specializations that would take somebody from no knowledge at all, except maybe a little bit of Python programming, to be able to, in TensorFlow in practice, to be able to meet the common scenarios that are needed in machine learning careers. And that's natural language processing, computer vision, and sequence modeling. The second specialization, data and deployment, is then taking the work that you've done in building machine learning models and making them real by putting them into mobile apps, by putting them into websites, by using them in JavaScript and things like that. And then the final one, TensorFlow from basics to mastery, is kind of going back a little bit to the model creation from TensorFlow in practice, but going deeper, learning how to extend your models, learning how to create custom, we have things in models called layers, learning how to create custom ones, and then looking at some of the advanced algorithms and being able to break them down so that you can understand them a little bit better. In that one, I'm afraid I broke my promise of not doing math because we had to do math a little bit in that, but we've tried to make it as approachable as possible. Direct at Scale is then we launched the TensorFlow YouTube channel, and we wanted to make that the go-to place where people could have short, quick lessons, either about how to do something in TensorFlow or what is happening in TensorFlow, new releases, all of those kind of things. We also put together a number of hands-on code labs, again, aimed at people. You don't need a PhD on math. You sit down, you start coding, and you start building out concepts. And it's in line with the 3 pillars that I spoke about earlier on that we saw as what employers were looking for. And that's computer vision, natural language processing, and sequence modeling. And then we've also been working through a number of different Google training initiatives. And I created a series for Google training. And I created another series as free training when people were at home in lockdown and those kind of things called ML Foundations. And all of that was being done direct at scale via YouTube and via other Google channels. And then, finally, sorry, just before I go on to the next one, and just as an example of how the model of being developer focused has been successful, Carmel Allison and I did a talk called Machine Learning Zero to Hero at Google I/O 2019 to test it out with the developer audience. So I'm trying to break the machine learning audience into 2. There are the people who are expert at machine learning and AI, and then there are the software developers who want to use machine learning and AI. And my focus has been on this second group. So Google I/O is the audience for them. And we did a talk at Google I/O that we called Machine Learning Zero to Hero, to take somebody in about 40 minutes to go from basic Python knowledge to be able to do some pretty complex computer vision. In this case, in the screenshots, I was teaching them how to do a computer vision exercise that recognizes rock, paper, or scissors. But again, when it was done very developer focused, one of the nice things we've learned about this one is the viewership of this video. We're approaching 1 million views on it. And when it comes to talks at Google I/O, this was far and away the most successful from the YouTube perspective. So we realized that we have resonance with developers with this type of message. And then the third one I mentioned is managed. And so this is where we have high touch managed efforts to train developers. And 2 of them that I show on the slide here. One of them is an academy in Indonesia called Bangkit. And Bangkit was an exclusive machine learning academy led by Google, working with the government and working with various startups, that we brought in 300 people. It was application-based. We trained them in machine learning, and the Indonesian government really wanted to be a part of this so that they could start seeding their startup ecosystem with people who are qualified and people who know the technology. And then the one at the bottom, as the Google Developers Machine Learning Bootcamp, is running in Korea. It actually started right at the end of October. And the idea behind this one is that Google and a number of companies, and many of whom are startups, got together to sponsor this bootcamp, but to make it a very different bootcamp. And that is the cohort of people coming into this bootcamp. If they pass the content in the bootcamp, they have a guaranteed job. I'm particularly excited about this one, given the economic situation at the moment because of the pandemic, that to be able to work together with industry to create a pipeline of people who are qualified to do a job, but to have the motivation for those folks to go through this bootcamp, to have a guaranteed job or internship at the end of it, I find wonderful. And all of this leads to what we call the employment-oriented developer certificate. So we've created a rigorous certificate exam. And this certificate exam is that once you pass that, you're proving that you can be a developer with computer vision, natural language processing, and sequence modeling. And this is also part of what we had with the Bangkit Academy and with the academy that I mentioned in Korea, the bootcamp I mentioned in Korea. The second half of this is to work with academia. So to work with universities. And so the number one thing that when I speak with professors at universities that I hear is that they would love to teach new courses, but every time you need to add a new undergraduate course, you have to get rid of an old undergraduate course because there's only so many that they can teach. And there's a great risk involved in teaching new courses. There's a lot of time involved in developing the curriculum, in training teaching assistants, and all of those kind of things. And as a result, there tends to be a lot of friction about adding new courses. And those of us who have graduated with computer science, I have half of a computer science degree, and I did half physics, half computer science. But I recall when I graduated, the skills that I learned to graduate were the skills of maybe 4 or 5 years prior to my graduation date. And the languages and frameworks that I needed to get a job on the date I graduated just weren't taught in academia. So we wanted to help try and solve that problem with machine learning. So we created a program where we help universities in developing courses. We provide them with the same curriculum that's used by the MOOCs, the same curriculum, code-first oriented curriculum that like we use in our own trainings and all of that kind of stuff, with support and in some cases some financial assistance to, for example, hire TAs and that kind of thing. And so we've launched that with a number of different universities. And again, the idea was to drive this towards an employment-oriented developer certificate and the same one as the professional folks had. So some of the results I'd like to share about this and the global impact of this. So first of all, the MOOCs, Coursera and Deep Learning AI, and the two specializations that we launched. As of now, when I'm recording this, we're over 600,000 learners, and it's growing exponentially. And this new specialization is launching next month. We think we're going to be getting, hopefully above 1 million learners by sometime next year. And one thing that the World Economic Forum did a jobs report about the jobs of the future and the jobs of the fourth industrial revolution that AI is being called. And they actually cited these MOOCs as a necessary skill. They listed a number of them, and the top two were Andrew Ng's deep learning specialization, which I learned from, a terrific specialization, and my specialization, the TensorFlow and Practice one, the ones that we created with each other. So, that it shows that it's landing well from an employability perspective, even recognized by the World Economic Forum jobs report. Udacity, also a MOOC, they launched an introduction to TensorFlow and some TensorFlow Lite courses, and they coming close to 200,000 learners. In China, the syllabus was used to create a course with a company called NetEase. And this launched just last week or middle of October by the time I'm filming this. And they have around 3,000 learners already. So we see that it's really beginning to pick up. And Udemy are launching some courses quite soon. So again, the syllabus, it's being used by multiple folks, by multiple providers. And we're seeing really nice numbers. With the universities, we've had dozens of universities globally that we've assisted in teaching the TensorFlow syllabus, as I described earlier on. But I want to call out a couple of highlights. Imperial College in London used this to create their teaching syllabus, but they also used this to create an massively online open course of their own that they teach on Coursera, which I found really exciting. One of the things we're really committed to with this is widening access as much as possible. So I've been talking about you don't just need a PhD and things like that, but we also want to widen access to people who are traditionally not represented in AI. And Keio University in Japan have launched a course for women. And we know that there is a representation problem in tech, a diversity problem in tech with having women in tech. And in Japan, it's particularly sharp because of some historic issues there. So Keio University really wanted to see if they could bring in more women into AI. And they are just launching, right around now, they're launching this course for women, being taught by women. And again, they became part of our university funding, the program that we set up. And this is one of the results that came out of it. And then given the issues globally and what we've been learning globally about racial issues and the fact that Black lives really do matter, one of the things that we've been trying to work very hard on is to work with historically Black colleges and universities in the USA to help them gain the benefits of the gifts that we can have with AI and to be able to take advantage of what the World Economic Forum was showing about the growth of jobs in AI and be able to train their students for that. Earlier, I mentioned the certificate program. We launched that in the middle of 2020. and early 2020, spring of 2020, and it's an employment-oriented certificate, a rigorous exam covering NLP, computer vision, and sequence modeling. And as of now, we have about 1,200 holders globally, and it is increasing nicely. And the vision here is that to really help people show their skills, but to help employers know that these skills have been shown. One massive part of the jobs gap was we discovered that a lot of employers didn't know how to find qualified AI people and didn't know the right questions to ask them. So we created the certificate program with that in mind. And then just to wrap up, I alluded to it a little bit earlier on, but part of the impact on this one is, we really want to help seed the economy. We really want to help train developers to be successful in the new economy. And I want to share some statistics about the state of employment globally. First of all, this chart, this is a general nice upwards trend chart, but there's a big dip at the bottom. And this is the chart of GDP I averaged that across several countries, UK, USA, and others. And you can see the general trend over about the past 35 years is that it's been mostly upwards. There's been a couple of little dips. But the problem when you chart something like this is you see a general upward trend and you think everything is fine, and you might miss some of the important nuances in this. So I recharted it as a derivative chart where instead of just showing the overall growth, I wanted to show the growth in any given year relative to the previous 2 years. And as a result, the same 35-year chart showed this. And this to me is really interesting because there are a couple of big peaks in this chart. One of them is here. And this one, I don't have the years on this one, but this one was from about 1993 through about 2007. And this was how the growth of the web and how the emergence of the web and the tech economy really changed the world economically, and this massive period of sustained growth. And it's no surprise, what are now the biggest companies in the world by market cap are all companies that came as a result of this growth. The Microsofts, the Apples, the Googles, all of those tech companies that are now giants came from this period of growth. And the second one here is the app economy. This is really the growth that came about as a result of the emergence of the smartphone. First introduced, I would say, you could argue, by Apple with the launch of the iPhone in 2007. I know there were other smartphones before that, but this economy really picked up then. Then the emergence and growth of Android and other platforms. And we've seen this as a really, really huge growth area. And while there's a big dip on the right because of COVID and because of the pandemic, we just want to realize that even like Apple this year released a statistic that said in 2020, the app ecosystem has grown by 300,000 jobs in the US alone. So we can see that jobs and employment are still very, very hot because of these two peaks. And the next peak, maybe in 10 years' time, if you look at a graph like this one, there'll be a new peak. And that's the fourth industrial revolution and the economy that comes as a result of AI. The World Economic Forum, for example, did a report where they wanted to look at the jobs of tomorrow, starting in 2020 and ending in 2022. And they had 5 categories: data and AI, engineering and cloud, people and culture, product development, sales and marketing. And far and away the biggest, as you can see here, was about a 37% growth in jobs between 2020 and 2022 in data and AI. And engineering and cloud computing, you can see, was plus 34%. A lot of that was around ML stuff in clouds also. So we can see it's a huge potential growth thing for jobs and employment. There's also a Forbes report, and I put the link to it here, that showed the global ML market will have a compound annual growth rate of about 44% between 2017 and 2024, from 1.5 billion to 20.8 billion. So it is a huge growth area. And AI software revenue, they also reported between 2018 and 2025 from 10 to 126 billion, which is a CAGR of 43%. So we can see here that there's definitely massive, massive growth in this area coming. You know, they're all the reports that I see tend to put it as a compound annual growth rate in the 40s. Both of these, 43 and 44%, support that. And even they mined LinkedIn to take a look at jobs, and 44,000 jobs in the USA required some kind of ML, and almost 100,000 globally required some kind of ML. So we can see ML, AI, these kind of skills are massively, massively important as we go forward. And we wanted to be the people to help train millions of developers to reach billions of people. And with that, I just want to say thank you, and I'll be able to answer any questions.
that was an amazing presentation, Lawrence. I'm glad that we actually got a good educational perspective to the field too. It's a very unique kind of talk, and I'm glad you all actually got to experience this too. So before we actually jump into the Q&A session with Lawrence, we've got a poll question for you. So where would you like your ML models to be or hosted? Right? And we have a couple of options here. To answer, you go to menti.com and enter the code 9975682. All of this is submit your reply. So I'm going to repeat the code again. So that's go to menti.com, and to answer this question, enter the code 9975682. And we'll be looking forward to your responses. Now, in the meantime, though, in the meantime now, we have a Q&A session with Lawrence. Everybody, let's just say, give a good clap and give a very warm welcome to Lawrence Moroney here. Woo! Yeah.
Oh, thank you so much. Thank you. Yeah. Can I answer that question with all of the above? No.
Yes, please do. You have an answer right now. Let's do it.
Yeah. So like where I want to deploy my models, absolutely everywhere.
Everywhere. You know what? Everywhere. It's like all the options. What's the correct option? Everything.
Everything.
All right.
Models everywhere.
That's awesome. Well, right now, let's actually start with some amazing questions, because we kind of have some amazing questions right here. So actually, this is by Hossein. I hope I'm pronouncing your name right. But which do you think is a better option for the industry, TensorFlow or PyTorch?
Well, first of all, I'll start by saying I'm completely biased, given that I work on the TensorFlow team. I'm wearing a TensorFlow jacket and I'm drinking coffee from a TensorFlow mug. So I think my answer there is going to be TensorFlow. So if I take off my jacket and take off my mug, I think it's always good for everybody to learn as much as possible about everything. We welcome the great competition that we're getting with PyTorch. I think it's brilliant for the industry to have competition amongst the vendors. But I will answer that, despite that, I still think TensorFlow, just because of the number of different places that you can deploy TensorFlow models, right? From the massive cloud scale infrastructure with multi-node TPUs, all the way down to the tiny like microcontrollers and embedded systems, that your TensorFlow skills, regardless of what type of model you want to produce, there's a place for you to put it. And so like from the industry perspective, I think, I would strongly recommend, despite my jacket, I would still strongly recommend TensorFlow.
Yeah, definitely. I do know like that, PyTorch does abstract a lot of, hidden mechanisms that TensorFlow does provide. And like, while on one, it's kind of a trade-off, because on one side, TensorFlow is definitely more adaptable and controllable and flexible. Whereas with PyTorch, some people just find it an easier interface to just use in general.
Yep. I won't claim any kind of expertise in PyTorch. It's something that I need to learn more of, to be perfectly frank. But yeah, my focus has always been on enabling people to succeed with the technology. And it's one level is being able to build models, but the other level and more important level is having somewhere to deploy them. And I think, that deployment surface is a massive, massive strength of TensorFlow. And it's, where I think we distinguish ourselves across in ML. And that's why I'm particularly passionate about it.
Yeah, that's a great answer. And also, here's another question from Arjun Kumar. How do you recommend continuing to build your career after, completing like courses like yours or Enjurong's, for example?
Yeah, good question. I think practice is very important. I think like with any kind of coding, the more that you do it, the better you get at it. You begin to realize the pitfalls, you begin to realize like those tips, those tricks, those things that make you better at doing it. So ML is no exception in that regard. It's really practice. Doesn't have to be public with competitions on Kaggle or anything like that. And one thing that I always recommend is you find something that you're passionate about, and then there's got to be some data out there around something that you're passionate about, and start building models in that regard. And, just continue to practice and become a better model creator. And then once you have those models that, to practice, then in deploying those models, be it like a large scale, global, scalable infrastructures, or maybe just a single cell phone for yourself to use. But, the key with anything is, constantly practice to improve yourself.
Yeah, that's true. I've also about like practicing too and everything that is associated with this too. Like there are also like a number of people, I'm also like looking at a bunch of questions where there is that like mathematical aspect that is deep learning and machine learning. Whereas, TensorFlow is more of like, okay, let's kind of break things apart from a more practical aspect and then, dig deep into that way. So a question would be like, how do you kind of balance these two completely different notions of approaching machine learning and deep learning? Would you prefer one or the other, or somehow like a symbiotic relationship between like theory and practical applications when going on your like machine learning journey?
I like the term that you just used, symbiotic, because I think that's exactly right. But symbiotic, like, how do you start? And so they should be meshed together, but how do you get started? And I mean, I can say just for me personally, I hadn't done calculus in 30 years when I started looking into modern machine learning. And when the initial material that I was looking at was kind of teaching you how an optimizer works through gradient descent and tons of calculus, or, teaching you how a convolution works using mathematical and Greek notation, I'll admit I was lost. It was harder for me to follow it. But when it was like I started looking into this, like using code and primarily code, it's much easier for me to read and understand code. So then my symbiotic relationship began definitely on the practical coding side of it, so that now I can understand what a model is. Now I can understand how a model learns from parameters. Now I can see how backpropagation works and things like that. And then with all of that context around it, then to start going into the math and then seeing, now I see why I'm using calculus for gradient descent and all of those kind of things. So to really build that context around it so that I could understand it better. And that's why now it's very much that symbiotic relationship that, I could start building models without knowing any math. But once I started building models, if I wanted to build better models, then to start understanding what's going under the hood was necessary.
Yeah, that's completely true, because like I know there's a lot of people who are in school, especially like based on our polls, and maybe like in school you'll be like learning some very complex mathematics, like I don't know, like calculus, for example, like that you mentioned, and you're like, well, if it's just thrust at you, it's like, okay, but where do I use this? What am I going to do with it? I don't care, as long as I just pass this course, I'm good. But then when you're like, but I am interested in machine learning and deep learning, what do I need to do for that? Incoming calculus, just surreptitiously, it's like, hi again. And then you're like, exactly. Oh, so this is how you can use calculus to create like all of these machine learning, projects that, you see everywhere just being deployed. It's like, oh my God, there's self-driving cars. There's like this system that can detect your fraud, whether your activity is fraudulent. And yeah, just like the applications are endless, and all with calculus. So that's definitely very interesting to hear.
Yeah, but it's like, don't let that be the gatekeeper that prevents you from getting in. That if you're like me, that once you start reading calculus and your brain goes to sleep, that kind of stuff, you can really get started and start doing all of this stuff and be productive before you start getting into the math. But it's like, once you're at that productive level, then it becomes easier to get into the math because you've built that context around it, and it makes it much easier for you to do so. Sorry, you said you had another question.
I mean, we always have so many questions for you. They just keep pouring in. So, you've seen you've seen like TensorFlow just like, become this huge thing right in front of you. But do you have any reservations about TensorFlow? Like maybe somewhere along the way, TensorFlow could have done something better, and it's probably still something that's a big problem. Is there anything like that?
I don't think there's anything that I would consider to be a big problem now. I think one thing that would have been really nice to have earlier, but we then eventually had with TensorFlow 2, was to think about it in a more Pythonic way. Because early versions of TensorFlow were very much graph oriented. So you'd load all your stuff into a graph and then you execute like a session within a graph. And for me as a coder, as opposed to an AI person, that was a little bit alien to begin with. It was very hard, because you can't do step-by-step debugging and things like that. When we released TensorFlow 2, became with Eager by default, it became more Pythonic. So it made it much easier for the people who are coders to get up and running. And if there was any one thing that I had a time machine that I would change to do sooner, it would be that.
That's very fascinating. And I think we have like a final question over here.
Sure.
So so there are people with like some experience in like JavaScript and Python, and they're always like asking like, so which is the best language to start my machine learning journey? Do you have any specific thoughts on that?
Yeah, I think the best language to start your machine learning journey of those two is the one that you're most passionate about using. I know a lot of people who love JavaScript. I know a lot of people who hate JavaScript. I know a lot of people who love Python. I know a lot of people who hate it. If you don't have any particular affinity to either of them, my recommendation would be to start with Python, just because of the number of support libraries that are out there for the beyond machine learning part of it, the data science part of it, the drawing graphs and all of that kind of thing. So like I said, if you were going to pick one from scratch, I would say definitely Python, but there's certainly nothing wrong with JavaScript. The things you can do with TensorFlow.js are fabulous. And yeah, I think Jason's going to be talking about that at this conference later today, and he always shows amazing things.
Exactly. Yeah, I'm completely looking forward to that too. By the way, Lawrence, I think we are out of time for some questions, but thank you so much for answering all of our questions until now. And for our lovely audience here, of course, like we're always happy to have you. And if you guys, anyone here just did not get a chance to ask Lawrence your questions, or they didn't come up right now, feel free to reach out to him in his speaker room, even starting like right now after this call. So just be there. Lawrence, it was great having you right here, and we look forward to hear from you soon.
Yep, sounds good. Thanks, and I'll see you all in the speaker room.
Sweet, take care. Now, I asked you guys all a question, right? We had a little poll that was going on of where you would run your machine learning model. Did you forget? I hope you didn't forget. Don't forget, because it's right on screen right now. So now let's take a look at some of the results. And oh wow, looks like the answers are kind of split between different members of the audience, but it's more or less unanimous among people who would rather deploy models in the cloud over like any other platform, either on mobile or web. That's interesting, because it actually does make sense quite a bit too, because I think that like all of your models, for example, you don't want to use, your current computer's capacity and be constrained by hardware limits when you're actually, creating these models. So cool option. I probably would have gone for the same. Who knows? I don't know. And okay. Oh, by the way, we have some, we also have like some lightning talks, and sorry, we have a pretty cool surprise for you. And so we have spatial chat and an after party, and then there's like a Quake tournament that's going to go on, like we mentioned before, and it's going to be a free for all. So there's y'all just have to join in, have fun, and you can follow us on Twitter with MLConf EU just to get the access code and join us for the party. And with that, we're going to have a couple of lightning talks today that I'm going to pass the mic over to my co-MC, Sergey. Now, if you'll take it away.
Yeah, and as Ajay said, right, we're definitely going to have a cool lightning talks, right? I think we had already pretty cool speakers beforehand, right? But now we're going to have it even more dense, right? Even more exciting speakers in the question of like half an hour, right? So what I'm about to offer you is 4 speakers, 3 talks, right, in half an hour. So we're going to go from very diverse topics, starting from how to apply transfer learning and deep learning to such an industry as semiconductors, right? Because everybody can distinguish cats from dogs, right? But can you use deep learning for semiconductors? And Deepajan and Sachin going to be talking like how to do that and like what are implications. On the next speaker, like within the lightning talks, we're going to go and use R and Kubernetes for robots data. How cool is that? I mean, we're all talking about Python. We're all talking about using notebooks, right? But here we're going to use R and Kubernetes as a cluster setup and robots data. I think it almost sounds like Christmas for me. And to make it like even more exciting, we're going to make it even wider and more diverse. And we're going to talk about AutoML. So how to make your machine learning learn its own representations, right? And like what structures and auto magical ML essentially, right? So please give some virtual claps emojis in community channel. And since we have 4 times more speakers, you should send at least like 4 times more emojis as well. So please welcome our speakers.
Hi, everyone. So today we will be talking about deep transfer learning for computer vision, and we'll be covering a couple of real-world applications in the context of the semiconductor manufacturing industry at nanoscale. A bit about ourselves. So I'm Dipanjan. I'm a data science lead at Applied Materials, also a Google developer expert in machine learning and an author. Over to you, Sachin.
Thanks, Dipanjan. Hi, everyone. Okay, my name is Sachin. I lead the data science competence from Bangalore in Applied Materials. I have an experience of more than a decade handling multiple enterprise-wide use cases, and that's in this particular scenario, we'll be discussing about semiconductor industry related AI use cases. So let's jump into it, Dipanjan. Okay. So today we are going to talk about defect classification. So I think all of us know about Moore's law, where it states like every 2 years the transistors in a chip gets doubled, and how it is possible. Like it is possible by the atomic level engineering, what companies like Applied, day in, day out, they do. And for that, they need to develop these recipes, and these recipes are not easy to develop. The process engineers who work on these recipes have to deal with a lot of defects while refining these recipes. They deal with these high-end image capturing techniques, which these tools like laser tech and AFM, which is atomic force microscopic tools, are taken into account. And in these particular cases, some of these techniques are very destructive, where the wafers are destroyed. That's where AI can help by figuring out these defects and have a lot of cost savings and time savings. So I'll give you a quick overview of how we are leveraging AI techniques in defect detection for AI semiconductor manufacturing. So if we talk about the defects, like we deal with multiple type of defects. In this particular use case, we have defects like particle, large particle, small, fit and all. You can see there is a lot of noise and variations. So it was not easy to have one single algorithm or one single model to deal and find the whole classification done. What we have done here is we leverage multiple classifiers, a stacking technique where we input the image, then we do a lot of image processing through different techniques. We do the denoising, and then we feed that image into first level of classifier, which figures out whether there is a defect or not. If there is defect, then we try to figure out by second level of classifiers whether it's unknown or a large or a small defect. Even if we find that, then there are different type of image processing techniques we apply to bring the defect out of the background, and then we try to do further analysis, like whether there is noise or the threshold levels are, the noise levels are below threshold, so that we can directly go to the fourth level of classifiers, which are to decide the ultimate class, whether it's a bit or a particle. In this way, we try to leverage, transfer learning based techniques to figure out the classification approach what we have got. So I think Dipanjan will get more deeper into it, and we'll over to you, Dipanjan.
So here we try to apply a hybrid classification system where we fine-tune a pre-trained ResNet model to extract the deep features, and we also use traditional image processing-based features like gray level co-occurrence matrices and Zernick moment features, and we combine these to form a fusion feature vector, and we pass it through a deep learning net to do the final level of classification. And we also do some image augmentation, especially in cases where we have less data, just like in these cases, because we can't afford to have a lot of data, especially with regard to semiconductor level, electron microscope level scans. And we also leverage pre-trained models like ResNet 50 in the backend of a object detection model like a faster RCNN to detect and count the number of defects, because sometimes you also have to give the defect count besides the type of defect. With regard to our evaluation performance, as you can see, the performance is 95% on a holistic overview in terms of the 4 types of classifiers, and we do a per classifier level performance also to understand the level of performance we are getting at each specific hierarchy in our overall hierarchical classification system. Now we'll discuss about unsupervised learning case in the context of deep transfer learning. Over to you, Sachin.
Thank you, Dipanjan. So as we saw, like the last case, we had prior knowledge of type of defects, but that's not the case always. Like many of the times, we are not aware of how the defect is getting induced in this whole recipe. And there we need to do a lot of analysis, like what is the defect count, what are the morphology of the shape, what are the elements, like whether it's nitrogen, aluminum, like at different parts or different steps of a recipe, we can encounter, different foreign particles, which could result into defects. So because of lack of prior knowledge, we go to the unsupervised waste technique, where we have built an interface where a user can browse the location where we have got all these defect images. Once the images are fed to the system, we use the ResNet 50 model to extract the features. These feature vectors are then fed to algorithms, the various clustering algorithms of what we have got. You get the higher level of clustering, which is then provided to user to decide how many clusters they want. And then we go to the finer level of clustering, like agglomerative clustering or affine, affinity propagation clustering and all. Based on these clustering results, we figure out the right clusters as well as the outliers, and that is presented to the user. So this makes the whole process very reproducible and repeatable, which is otherwise very subjective between different manual users. So over to you, Dipanjan, to get more into details of this whole algo.
Yeah, so again, here we leverage a pre-trained ResNet model along with computer vision specific features like the heraldic features of the Zernick orthogonal projection moment features, and we get those fusion vectors, which we typically pass to our clustering models. And that is where we use hierarchical clustering in the terms of forming that dendrogram, getting that right level of cutoff, forming those clusters from the data itself. And then we also isolate the singleton clusters, which are basically very different from the regular clusters in terms of similar kinds of defects. And this is a view you can see in terms of the interface, which can show the different clusters to the user, and then they can save it and leverage it in the future to even feed it to a supervised learning problem. And that brings an end to our whirlwind tour of deep transfer learning for computer vision. Thank you.
Thank you.
Hello, thank you very much for your interest in this talk. My name is Frans van den Neen. I'm the Chief Data Officer at Expantia, and we help organizations to boost their data analytics capacity. This talk was prepared together with Florian Pistoni. Florian is the co-founder and CEO of Inorbit, and Inorbit is a cloud robot management platform, and they are taking robots, developing that further to take robot operations at a global scale. Right? Because robots are everywhere now. Where you look, even more now with COVID, they're working alongside with humans, they're working autonomously, and it means that the volume of the data that we're gathering from robots is increasing exponentially. Of course, this offers very interesting chances for us data scientists to work with a kind of data that has some special characteristics. And if we look at what Inorbit has been doing, they have accumulated more than 3.8 million hours of robot data in the last 12 months alone, and they're growing rapidly, right? So right now they're adding about a year's worth of data each and every day. Now, for us to do analysis on that, even though this is a lightning talk, it's very briefly, but I want to highlight some of the issues we found and how we've solved it. So the main problem we found is that Inorbit offers their services to any fleet. We have no control of how exactly those data are being gathered and how they're sent to the central service. So in one of the POCs we did, we were faced with many robots that were sending millions of files, right? One file every 5 seconds for every agent. But each file contained data of multiple sources. And each of those sources were in robot or in agent operations. They had their own timestamps. They were not directly related. So in the first step that we needed to do was data extraction. And this was a little bit more complex than we expected, especially because we needed to join observations by nearest timestamp. I will highlight that a little bit in one slide further. And then do the feature engineering on top of that. So what I mean with nearest time joining, we have different signals about mission, localization, and speed. And we need to find an interval where we can join each and every one of those signals to have a single observation. We worked out how that could be done. And then we needed to start the feature engineering. So once we have one line, one observation for per time unit, we wanted to look back. We wanted to look back at what happened before a failure. So there's a failure right here. And if we go back, say, 42 seconds, then we need to do that for each and every one. Doing that for, and taking into account all the cases where we couldn't include the datum, for instance, when there was a failure within that 42-second time frame, was absolutely possible. But then we were faced with an enormous volume where our local computers simply said, no, this is not going to be possible. So we immediately thought about farming this out to Kubernetes. We set up a bucket with data that was going in. We packaged them in one-day zips. We packaged each of the JSON GZ zips to make it a little bit more workable and to be able to transport the data with more ease. Then farm out the full data extraction of Kubernetes. A second bucket with the intermediate result, farm out the data engineering. We have the result ready for analysis. What we found is that it is much easier to get the help of something called Pachyderm. So Pachyderm is a product. It's a company. They have an open source version of this, which is what we use. And what we have there is not a bucket. What we have is a filing cabinet. We have a repository where we can version the data that is coming in and version the data that is coming out. Doing this kind of data pipeline with versioning means that if there's one change at any point in the pipeline, the rest of the pipeline will respond and will update the data automatically. So that prepares us to do all to have all the heavy lifting ready once we bring this into production. Just a quick look what this looks like. We create pipelines that are very similar to your Kubernetes configuration files. And the key thing here is that we can connect the data in the repository, in the Pachyderm repository. PFS is the Pachyderm file system, to what we're running in our R script. Because our R scripts, they were already parallelized, but parallelizing was not enough. So we were now able to farm this out, making that connection, setting whatever data preparation rules we're doing next. And for each datum, that is sort of the Pachyderm term for what each unit of data in the pipeline is, we can see whether it was successful or whether it failed, right? This is a screen from Patrick Santamaria, who I did most of this work with. So being able to monitor on that level what is happening with your data is, in practice, it was absolutely great. Right, so parallelizing our code, it's easy. There's a package called Fur built on Future by Henrik Bengstam, and it's very easy to parallelize it out. Going from parallel R code to a massively parallel pipeline is doable, thanks to Pachyderm. For us, it was much easier to work with Kubernetes through that. The other thing was that large clusters are surprisingly affordable, right? We worked on an 80 CPU, 520 gigabyte RAM cluster for under $10 an hour, which was something we hadn't experienced before, and now we are using more and more in the work that we're doing. For the team that we were working with, for InOrbit, this also has huge implications, because it means that as fleets grow, they know that collecting and processing data becomes critical for them. They also now know that where they understand the scaling of their full platform, it doesn't need to be hard, but scaling up the analysis doesn't need to be hard either. And using AI at the robot fleet level, unlocks many new opportunities that they are working hard on to continue to offer to their customers. Thank you very much. I hope that this was useful. If you want any further information, please visit our websites, expantia.com or inorbit.ai. We both have blogs running, and we like to write about this stuff. So we hope to be in touch sometime in the future. So thank you very much.
Hello, everyone. My name is Bernhard Zoom. I'm product manager for machine learning with the MathWorks. Let me motivate my topic with some questions to you. Where do you want to apply AI? Are you concerned with the lack of your experience in AI or with black box models? The community widely recognizes these as challenges and barriers to broader adoption of AI across many industries. Today, I will focus on AutoML, automation that takes the routine iterative effort and most of the science out of building machine learning models. So what exactly is AutoML? To understand that, you need to know a bit about the typical workflow for building machine learning models. The focus of this talk. But building deep neural networks isn't that different. First, you need to process your raw data, deal with its messiness, and get it into a shape that's suitable for later stages, like dealing with missing data and outliers. Next, you need to engineer features, extract a few variables from your data that serve as input to your model, and capture the majority of the variability. That's fairly easy for numeric data, but a lot harder for signals. Next, you're faced with the choice of different machine learning models. And even to experts, it's not clear which model performs best on any given problem. So you have to try multiple, which leads to the model tuning stage, where you assess the performance of some initial models, optimize their hyperparameters, maybe select a subset of features to avoid overfitting, but that may not be enough to get really good performance. You may have to go back, replace some features with others, and do this all over again. If you're familiar with machine learning, you will know the most difficult and time-consuming stages are the feature engineering and the optimization. If your head is spinning now, don't despair, because you don't have to know all this complexity. The point of AutoML is to simplify it, ideally to go directly from your initial data and your machine learning problem to a model you can deploy. However, really taking it seriously, that is not a realistic expectation. In a single-step machine learning is not possible. However, what is realistic is freeing up engineers like yourself to focus on the hard machine learning problems and on your application. Otherwise, without AutoML, you'll have to find that AI expertise either inside your team and organization or outside. And those data scientists are hard to find and expensive. So as the first barrier that AutoML removes, it overcomes the lack of machine learning expertise. But even if you have that expertise, you are increased in productivity because AutoML takes away those time-consuming and iterative steps. Finally, AutoML allows you to solve problems that otherwise wouldn't be feasible, like use cases where you need to build many different models representing different variations or different environmental stages. So how do you apply AutoML for engineering? Most of those engineering applications are based on signal and image data, and that's where the feature engineering becomes critical for good performance, and that's notoriously difficult. We at MathWorks brought our signal processing knowledge to bear and came up with the following three-step AutoML. First, you apply wavelet scattering. These wavelets are very suitable in their time-bounded shape to represent spikes and irregularities in your signal. Therefore, you get very good features. Many engineering applications, however, require deployment to memory and power-limited embedded systems. For those, you cannot deploy large models. So second, we apply automated feature selection to reduce the maybe hundreds of wavelet features to just a few very performant features and reduce the model size. Finally, and key is the model selection hyperparameter tuning step. You have a choice of different models, and for the model to perform well, the hyperparameters need to be set just right. Let's look at that stage in a little more detail. How does that simultaneous optimization of model and hyperparameters work? Well, you can perform random search, but that's not efficient either because the search base is very large. We employ Bayesian optimization that builds a model of the search space. And here you can see how that Bayesian optimization switches between different types of models and optimizes the error in the course of the iterations. How do we know that AutoML works? We compared AutoML to the traditional manual process on two classification problems. First, we looked at human activity recognition, where you take accelerometer data from mobile phones. We have about 7K observations in the set we collected, and we manually engineered 66 features using various signal processing functions. Second, we looked at heart sound classification. Think about being in your doctor's office with a stethoscope and listening to your heart sound. So those phonograms, we could have a data set of 10K observations that's publicly available and engineered less than 30 features. So what results did we get? You can see here with the manual process, we achieved accuracies in the high 90s as you would want to have for such an important application. For AutoML, for one application, it's slightly lower, but the point is, without all that expertise and without the time-consuming iterative process, you get very good models in a few steps. So AutoML empowers engineers without AI expertise to build optimized models, including for signal applications where the feature extraction is notoriously difficult. You can apply AutoML to signal applications in a few steps. Automated feature generation with wavelets, automated feature selection to reduce model size and make it fit on your hardware, and model selection along with hyperparameter tuning in an efficient way using Bayesian optimization. Finally, to deploy your AI model to the edge and embedded systems, you need low-level code like C. MATLAB, you can translate automatically to C, C++ code that can be deployed directly, and thus another barrier to broader adoption of AI removed. Thank you for your attention. And if you want to know more, Monday afternoon or evening, I'll have a longer session on AutoML and interpretability. A seminar on those two topics, 1 hour, and 2 hours a hands-on workshop on machine and deep learning using MATLAB online. And now I'll head back to the moderator for questions.
Yeah, that was like really dense and informative 30 minutes of our time, right? Thank you again, Dipajan, Sachin, Franz, and Bernhard for this very diverse and interesting talks. And now I'm happy to actually welcome them to the stage so we can answer your questions that hopefully you were asking on Discord. So please get your round of virtual applause. Hey people, welcome, welcome. How's it going for you? I heard that you're also coming from very diverse and geographically far away countries. So maybe if you could just say like what time is it for you, right? And where are you located geographically?
Yeah, sure. I'm in Bangalore, India. It's just past midnight now. Definitely diverse locations.
Same like Dipanjan, Bangalore, India.
Nice.
I'm in Costa Rica, so it's well past lunch now. It's almost 1 o'clock.
And I'm located on the East Coast in the US, so it's just 2 o'clock in the afternoon.
Wow, that sounds like a future, right? Because usually you're having people, I don't know, maybe in 3 different rooms, right? And now we're covering like 3 continents, if I'm good, 2 continents, depends how you count. Anyway, so let's try to get to some questions. First of all, thank you for delivering such amazing talk. And I will just start with some questions and hopefully we will have some other questions arriving meanwhile. So first question would be maybe to Dipanjan and Sachin. So, you know, people always trying to start with, with images, right? Because it's like very representative, right? They can see there are like cats and dogs, right? And they start to train some convolution neural networks, right? To distinguish them. And now you're doing like semiconductors, right? What were the biggest, you know, like discoveries and learnings, like in comparison doing like normal convolutional classification, right? For flowers or cats and dogs, right? And you doing semiconductors, or it's just like different images, but at the end of the day, it's like the same story.
Yeah, Sachin, maybe you want to talk a bit about where sometimes deep learning doesn't always work in, and we have to go for traditional computer vision also.
Absolutely. So again, like, traditionally I've been using cats and dogs and all in terms of data sets, but when it comes to semiconductor oriented use cases, so first of all, the image, the procurement of the image is dependent upon very sophisticated instruments, and the problems what we deal, the scale is like, okay, finding an ant in the area of Manhattan. So you need to be pretty precise, and sometimes the problems are not, that easy to tackle with neural networks and all. So there we need to do a lot of manual feature extractions where the computer vision techniques are required. So that is one aspect of it. The other aspects are, even if we are going with a deep learning approach, I think that there is still a lot of process to do in terms of denoising the images and all, building those pipelines which can, support the underlying neural networks to do the feature extractions in a way like we can use them for the later stages, be it for classification or other aspects. So these are the challenges what we face in general. Dipanjan, you want to add something?
Yeah, and as you may have seen in our talk, it's not just about the pre-trained features or let's say deep features from your pre-trained models, but we had to look at custom kernels also, like the gray level features from the Haralick or the Zernich orthogonal features. So definitely we have to augment our feature set and build like a hybrid model. So it's not always that deep learning model works out of the box. You dump your images and you get the features. You may need to look into traditional computer vision and image processing based features also. And like Sachin mentioned, you may have to do a fair bit of denoising, use a lot of those filtering methods to denoise the data before you pass it through a deep learning model.
Nice, well done, well done. Cool, I got another question from Tobias or Tobias, depending like where is he coming from. So this one is actually coming for France. So as your talk was quite fast, I would like to, if you can expand a bit more and reiterate how you process those gigantic amount of data through those parallel pipelines that you mentioned. Because I guess people also say that, hey, R is not like the fastest, right? And the most big data solutions that people have, right? So if you can drop a couple of words on how can you process a gigantic amount of data.
I think that is maybe almost a myth right now, right? So R is a great language because of its accessibility. So there's many people where we work with, and our customers, most are in a data science team in a business setting. So for them to adopt R is much more natural, much easier than to do that with Python, for instance, which, if you have an engineering background is maybe easier, but if not, it's definitely not. So what we've seen in the past few years is that, multi-threading with the great work of Henrik Bensten in the future package has improved a lot. And the way that we can now deploy on cluster infrastructure with Spark R, or in this case, to use Kubernetes to scale out even further, is great. And the technology we used in this particular case, Pachyderm, is completely language agnostic. Really, it does not matter what language you put in, whether it's R or Python or Go or whatever you prefer to use, because the scaling up is just container-based. So as soon as you make a container that can accept data and then has an output in data, you can scale it up. And Pachyderm worked really well with that. They have some great examples on their website for you to try it out in whichever language you work.
Nice. Yeah, I totally agree with you that the right language, right, or the right tool in many cases can deliver way more than you're trying to get the most trendy one, right? And additionally, there's also like RCPP, right, that allows you to write some bindings also like in C++ if you want, right? So it's up to you to decide whatever your destiny is, right?
Sure. There's now native access to Torch, right? There's RTorch now.
Nice.
Even there, it's really whatever you prefer and works best for you.
Yeah, cool. Now another question would be also from Tobias, but to Bernhard. The question is the following, right? Can you imagine cases where AutoML could fail and how you can prevent it? Examples that he's bringing is maybe if dataset has special fields, let's say IDs or something similar. Is it something that you need to pre-process before AutoML? And maybe you have some stories like where things went completely crazy.
Yeah, well, AutoML is not a silver bullet. It's a tool that helps you find an optimized model without having to try out all kinds of different models. Now, depending on your problem, certain models may not work well, and that will surface then in AutoML the way I described it, with the automated model selection process that leverages Bayesian optimization. I have to say that particular problem case you mentioned, I'm not familiar with, so maybe we'll take this offline.
Definitely. And since you already mentioned Bayesian optimization, there's another question from Sanchit, and he's asking like, hey, why Bayesian optimization? I guess people like this one, but have you compared it with gradient optimization or reinforcement learning or evolutionary algorithms? Because I think evolutionary strategies especially kind of like become at some point also like a hot trend. So how do you feel? Is it Bayesian all the way, or are there like any good corners for other tools as well for AutoML?
Yeah, well, I mostly compare it to, so for hyperparameter optimization, Bayesian optimization is very efficient and used frequently. You cannot really use gradient descent, since many hyperparameters are, they are not continuous value, they're discrete. So Bayesian optimization builds its own model of the hyperparameter space. And then you also, compared to some of these other models, you don't have to evaluate the objective functions as many times, so it can be more efficient. Not exactly sure about evolutionary algorithms, but certainly compared to gradient descent.
Mm-hmm. Yeah, that's a good point. It feels like that AutoML is getting quite a bunch of attention in terms of questions. So there is another one from Tobias, and he's asking like, hey, can you expand on how and if AutoML deals with possible missing data problems, like missing not at random?
Well, so dealing with missing data is sort of, it's an early stage in the machine learning workflow, the way I described it in the data preparation. And there are, there are approaches available to deal with missing data at that stage. And then later, I went into feature extraction and model selection. At that point, the assumption is that you have appropriately dealt with missing data.
Nice, thank you for your answer. Maybe another one to Franz, right? I do like that you're advocating quite actively for R. How would you think, like, if you have a new graduate, right, back from the university, right, and they just start their journey in machine learning and data science, right? What would be the language you would suggest to those people, right? Or like a good roadmap, basically starting from, hey, I got my bachelor degree, right, a master's degree, and what would be like a good starting point?
Sure. It depends a little bit on what field you come from, right? Again, if you're from an engineering field, then you have your set of languages that might be easier to go through. In my experience, people coming from fields like sociology, biology, like myself, actually have a good basis to start a career in data science. And for most of them, in my experience, R is easier to start, not only because of the language, but also because of the community. Right, the way they interact, the things that they talk about. So try out what works best for you. That would be my main recommendation, right? Try to solve a real problem, and then with the tools that you found to solve that problem, dive deeper into them as you go along and continue to practice.
Yeah, no, I completely agree with you. I think the patient in many cases open up like way more doors, right? That having like a right tool, right? Because it means that you are comfortable, that you can invest more hours, right? And you're kind of like making it more exciting for yourself, right? To learn. Cool. Maybe another question to Deepajan and Sachin. So like you mentioned that you can use some parts of classical computer vision, right? And there is also like a deep learning. How do you feel? Do you need sometimes like to justify to those companies like, hey, I want to use deep learning, right? Or they want to like, hey, I want to have something that you can explain with if-else statements, right? And how it's actually working, or how complicated is the problem in terms of explainability?
Yeah, I think explainability is a big challenge, especially with unstructured data like images or audio or even text. I think text, you are nowadays getting a lot of things, but with images, it is always a challenge because you're dealing with multidimensional data, and it's not like you can compress everything into if-else rules like you can do with structured data where you have methods like SHAP or LIME. But some techniques which have been working well are like you have deep SHAP where you use GradCam-based gradients along with Shapley values, and you have GradCam-based methods also. So those are, at least I would think, is a step in the right direction to explain as to why is a classification working in a certain way, at least. But I think there's still a long way to go. Sachin, you can add in some comments also maybe around GradCam and some of these techniques which may be promising.
So, absolutely, Dipanjan. So as you know, as the traditional approaches are more describable, like you can decipher them and describe like where the things are coming from. So we have started using, because these asks are coming to us where we need to explain like, okay, why this inference is coming from the model, where we have explored things like GradCam++, and all, Shapley's and all are, as Dipanjan has explained. And if you want to be in this game, then definitely explainable AI is something which we need to leverage and have in our arsenal, because over the period of time, the cost associated with these inferences is quite high in semiconductor industry, and we need to have that justification behind whatever model is predicting to have that adoption rate high. So I feel like these are the things which we need to work on also.
Yeah, we need to explain like why is it happening, not just say that it's a yes or a no. So definitely XAI is becoming bigger and bigger, because it's not just about the technical method, but the value which is obtained from being able to explain it in a more transparent manner.
Awesome. Thank you for your answers and for delivering such amazing and diverse talks. It was a pleasure listening to those. Have fun and see you later.
Thanks a lot.
Thank you.
Yeah, and as I mentioned, we have like very different speakers from different countries, from different domains, right? And they're solving different problems. It's the same we wanted to have for our audience, right? We didn't want to have people having, very boring and coming from the same, like either the same gender, right? Or from the same country. We wanted to make them like diverse, right? And very interesting to the audience. And for that, we had Firebase, who is our diversity sponsor, who actually allowed us to offer some tickets for people coming from underrepresented communities or groups, right? And thank you again, Firebase, for doing that. Yeah, and for those of you who got excited about all of those amazing ideas, and I don't know, maybe you also want to train some robots, please take a look at our MLConf EU/jobs. Maybe there is something interesting for you and you can get a new exciting challenge for yourself. The next one is Metin, who's gonna present a new speaker.
Well, I guess that's me. Thanks, Sergey. I have some good news and I have some bad news. Let's start with the good news. The after party is, like AJ said just before, it's open for everyone. So even if you don't have a paid ticket, you can join in on the fun and shoot some people in Quake.js, or you can join the spatial chat. The bad news is this is already the last talk of the day. Okay, I know we have more talks coming tomorrow, but yeah, we're gonna call it a day after Jason's talk. So who is Jason? Jason Mays is working at Google, and he's gonna give us a talk about TensorFlow.js. So his talk is aimed at JavaScript developers, getting them into machine learning with using TensorFlow.js. When we reached out to Jason to get to know him a little bit better, we wanted to know what his favorite movie was. And he said, well, I don't have a favorite movie. There's too many great ones to choose from. And I guess that's a really hard question. For me, I also wouldn't know from the top of my head what my favorite movie was. But Jason said it would definitely be a sci-fi. Same with food. He said there's too many great foods. Again, I agree, but it would be some Thai cuisine. So nice, tasty. I can agree also. And when we wanted to know, what did you want to be when you were growing up? Jason, the kid, what did he want to be? And he said he wanted to be an astronaut. Well, I don't know how he's going to become an astronaut from his machine learning background, but hey, maybe one day. He mentioned that he's now on the waiting list for Virgin Galactic, so fingers crossed. So we're going to go to his talk right now. So I think it's time again. It's that time of the year for some virtual clap emojis in the community channel. So everybody, give it up for Jason.
Hello everyone, my name is Jason Mays. I'm developer advocate for TensorFlow.js here at Google, and I'm excited to be talking to you about machine learning in the browser and beyond. So let's get started. Now, first off, why would you want to use machine learning in JavaScript? That's a great question. And if we look here, we can see that we can use machine learning anywhere JavaScript can run. And that's actually a lot of places: the web browser, server-side, desktop, mobile, and even Internet of Things. And if we dive into each one of these areas a bit more, we can see many of the technologies we know and love already. The common web browsers there on the left-hand side, Node.js for server-side execution, React Native for mobile native apps, Electron for desktop native apps, and even Raspberry Pi for Internet of Things. And JavaScript is one of the only languages that can run across all of these environments without additional plugins. And that alone is very, very powerful. And with TensorFlow.js, you can run, retrain via transfer learning, or write your own machine learning models completely from scratch if you choose to do so, just like you might be doing in Python right now, but in JavaScript. And that means you can make anything you might dream up, from augmented reality, sound recognition, sentiment analysis, and much, much more. It's really up to you what you create. Now with TensorFlow.js, we've got a number of different ways you can use us. The first way, and the easiest way, is to use our pre-trained models. These are super easy to use JavaScript classes for many common use cases, like we can see on the current slide. And here we can see things like object detection, body segmentation, pose estimation, face landmark detection, and much, much more. Even natural language processing is supported in the browser. So let's see some of these in action. Now, first up is object recognition. This is using Cocoa SSD behind the scenes and is trained on 90 object classes. You can see this in action on the right-hand side, with the dogs being highlighted with their bounding boxes. And we can even know that there's 2 dogs in this image, as both are returned to us. So let's see this in action live to see how it performs in the browser. Okay, so here's a web page I created that's running this code live in Chrome. And if I click on any one of these images, I can now get object detection working for any objects it finds in those images, even if it's different object class types. But we can do better than this. We can actually enable the webcam and then do this live in real time. And you can see me talking to you right now, and you can see how it's classifying both myself and the bed in the background sometimes as I speak to you. And this is super cool because not only is this running at a very high frames per second live in JavaScript, this is running client-side in the browser. So that means none of this webcam imagery is being sent to a server for classification. Not only does that save cost, it also means my privacy is preserved. And that's a really big thing these days. And with TensorFlow.js, you can get that for free. So next up, we've got Face Mesh. This is just 3 megabytes in size and can recognize 468 facial landmarks on the human face. You can see this in action on the left-hand side of the slide right now. Now, people are starting to use this for real-world use cases, such as L'Oreal, and they've created AR Makeup Try-On, which allows you to try on lipstick in this case in real time without even having to be there physically present in the store. So you should note, the lady on the right-hand side is not wearing any lipstick. We're using Face Mesh to understand where her lips are, and then we use WebGL shaders to augment the color of lipstick she wants on her face in real time. So this is super cool, and I'm sure we're going to see more stuff like this coming out in the future. So let's see Face Mesh in action to see how it performs in the real world. Let's switch to the demo. Okay, so now you can see me talking to you with Face Mesh running in real time in the web browser at the same time. On the left-hand side here, you can see the machine learning in action, and there is indeed a mesh of my face being overlaid as I move my face around, and it's pretty robust. I can open and close my mouth, and my eyes, and you can see that happening all in real time. And we're getting a pretty solid 25 frames a second or so as I'm running on my GPU via WebGL. Now, of course, I'm also streaming this live, so I'm using some of my GPU resources right now. I could get higher frames per second if I desired, but I can also switch as a developer to WASM, which is WebAssembly, to execute on a performant way on the CPU, or I can choose to execute on the CPU by itself, which is the slowest form of execution. So there's a number of options on where you can deploy to. And because this is JavaScript, not only am I doing the machine learning there on the left-hand side, I'm also able to render this 3D point cloud of the results on the right-hand side using 3.js. And JavaScript from day one has been designed for the presentation and display of information, so we've got really rich libraries, especially for 3D graphics, to be able to do this very, very easily. And you can see I can move it around and now inspect my face from different angles, which is being constructed in real time live in the browser. Okay, back to the slides. So next up is body segmentation. This allows you to distinguish 24 body areas across multiple bodies all in real time. You can see this in action on the slide, and on the right hand side you can see that the different colors represent different parts of each body. Even better, we've got pose estimation going on at the same time, those light blue lines contained with each one of the bodies on the right hand side there, which allow us to estimate where the human skeleton is. And with that can enable really powerful demos, such as the ability to recognize when you're in a certain pose, or a gesture, or something like this. We've already seen people in our community use this to do workout instructors or yoga instructors and this kind of stuff. So it's super cool to see the creative potential of this model. And in fact, with a bit of creativity, we can use things like body pics in a number of delightful ways. Here's just two examples I created in my spare time. On the left-hand side, you can see me becoming invisible as I walk around on my bed. And notice when I walk on the bed still deforms. And this is, more powerful than just a cheap trick where you're just replacing the background image with a static image. I'm able to calculate the background updates in real time and only remove my body from the parts where my body actually is. And of course, it's not perfect, but it's the first steps, and this was made in just a day. So very, very cool stuff. And you can see here how JavaScript can allow you to prototype ideas very, very rapidly. On the right-hand side, I also made a clothing size estimator. Now, I don't know about you, but I'm really terrible at knowing what size clothing I am when I'm trying to buy clothes once a year. And for different brands, I'm different sizes. In some brands, I'm a small, other brands, I'm a medium. So I never know what to select at checkout. Now here, I can, in under 15 seconds, get an estimate of my body size for the key measurements that they care about for that particular brand, and I can automatically select at checkout the correct size for me. And that saves me time and money of having to return things when they don't fit. And this solved a problem I had in my daily life. Next up, what about giving yourself superpowers? One guy from our community combined our face mesh model with WebGL shaders to create this Iron Man-like effect. And here you can see lasers coming from his eyes and mouth in a really beautiful, realistic kind of way, which could be great for an activation with a movie company or something like this for a new movie release. Or what about if you combine with other technologies? Here we see another member of the community using WebXR and WebGL and TensorFlow.js together to extract an image of a body from a magazine and then bring that body into the real world so they can inspect the fashion design in more detail. I've even seen this person go one step further and make the face animate and say sounds, which is really, really cool. But why stop there? We can go one step further still. By adding WebRTC to this, which stands for Web Real-Time Communication, I can even teleport myself. Here, I can segment my body using body pics from my room. I can transmit that segmentation over the internet and then reconstruct it in a real physical space using WebXR. And this allows me to speak to my friends and family in the current times where we're not able to travel as much in a more meaningful way than a rectangular video call. In fact, maybe in the future, my future presentations will be delivered to you in this form, who knows, but some very exciting stuff ahead. Now, the second way to use TensorFlow.js is via transfer learning, and this allows you to retrain existing models to work with your own custom data. Now, of course, if you're a machine learning expert, you can do this all programmatically. But today I want to show you 2 easier ways to get started. Now, the first is Teachable Machine. This is a website that can do both the training and the inference completely in the web browser. This is great for prototyping for things like object detection, pose estimation, and sound detection. I think more models will be supported in the future, so watch this space. But let's see it in action to give you a flavor of how it works. Okay, so if we head over to teachablemachine.withgoogle.com, you can follow along if you like. We can actually select one of 3 projects to choose from. Today, we're going to go for image project to recognize a custom object. So we click on that, and we're then presented with a screen like this. On the left, we've got a number of classes for the objects we want to recognize. If we want to recognize more than 2 things, we can click the nice Add Class button here if we choose to do so. But today, we're just going to recognize my face or a deck of playing cards. So let's go ahead and give it some more meaningful names. I'm going to call the first one Jason to represent me. And the second class I'm going to call Cards, which represents the cards. Now all we need to do is allow access to our webcam, and you'll see a live preview pop up on the left-hand side for the first class. Now I just need to record some samples of my face to make sure we have some training data for this class type. So let's go ahead and do that. I'm going to move my head around to get some variety. There we go. And we can see that I've got, how many images have I got there? About 38 sample images. Perfect. I'm now going to go and do the same thing with class number 2, the deck of cards. And I've got here a nice set of playing cards. So what I'm going to do is hold to record again, but this time I'm going to get roughly the same number of images, but of the cards. So I've got 42 there. That's close enough. All I need to do now is click on Train Model. And now live in the web browser, this is going to attempt to categorize the training data that I've presented to it versus the ones it was previously taught on. And you can see there in under 30 seconds, it's already complete. And it's currently predicting Jason as the output with 99% confidence, which is pretty good. And if I bring my deck of playing cards up, you can see that switches to cards with 100% confidence. So Jason, cards, Jason, cards. And you can see how easy that was to make and how robust it is in actually detecting those 2 objects. Now, of course, this is a prototype. If this was good enough for what I needed, I can click on Export Model here. I can click on the Download button. And of course, I can then copy this code and use it on my own website if I choose to do so. So that's Teachable Machine and great for prototyping. However, if you've got gigabytes of data, you might want to use something more robust for production quality models. So let's go back to the slides and see how to do that. So Cloud AutoML allows us to train custom vision models in the cloud, and we can deploy to TensorFlow.js at the end, which is super useful. So all you have to do is upload folders of images that you want to classify to Google Cloud Storage, as you can see here, and then click on the next button. Once you do that, you'll be asked if you want to optimize your model for higher accuracy or faster predictions, or some kind of trade-off between the 2. You then set a budget and leave it training for hours or days, depending how much data you've got uploaded there, and it will come back to you with the best results. It's going to try many different hyperparameters, many different types of computer vision models, and try and figure out what works best with your data. Once it's ready, you can then click Export and choose TensorFlow.js as shown here in the circle, which will download the model.json files which you need to run in the web browser. And with that, you can then use it on your own web page and add your own user experience and user interface and so on and so forth. You might be wondering, well, how hard is it to actually use this production quality trained model? And actually, it's super simple. In fact, it's so simple it fits on one slide. So let's walk through this code. First, we're going to import the TensorFlow.js library using this script tag. Second, we're going to import the AutoML library with the second script tag. Below this, I've created an image, which is just a DAISY image, which I found somewhere on the internet. This is the image we want to classify. This could be something else like a frame from the webcam or whatever it might be. But this I've just taken for simplicity, a daisy.jpg. Now, the meat of the code is in these 3 lines of JavaScript here. The first one simply calls await tf.automl load image classification and then we pass to it model.json. So model.json here is the file we downloaded in the previous page. And this will be hosted somewhere on your content delivery network or your web server. Now, because this is an asynchronous operation, we have to use the await keyword in JavaScript to tell JavaScript to wait for that to finish before continuing sequentially thereafter. So once that's loaded, because the model might be a couple of megabytes in size, we can then move on to the next step. So next, we grab a reference to the image we want to classify. So in this case, we call document.getElementById Daisy, which is referring to the Daisy image above here. And now we've got a reference to that in memory. All we need to do now is call await model.classify and pass it the image we want to classify. And this again is an asynchronous operation because this might take several milliseconds to execute, which of course in computer terms is a very long time. So we want to wait for that to finish. And then we'll have a JSON object assigned to this predictions constant here on the left, which you can then iterate through and go through all the things it thinks it's found in the image. And with that, you can do whatever you like. You can trigger something to run, you could control a robot, you could do whatever you wanted to do just with a few lines of code. So super cool and super functional. Now, the third way to use TensorFlow.js is to write your own code. And of course, to go through that would be a whole different talk in itself. So today I'm going to focus on the superpowers and performance benefits of why you might want to consider using TensorFlow.js in the browser. Now, first up, I want to give you an overview of how our API is structured. We've got two APIs. One is the high-level layers API, which is very similar to Keras if you're familiar with Python. In fact, if you use Keras, it's basically the same function signatures, so you should feel very much at home. And then for those of you who want to go lower level, we have the Ops API, which is the more mathematical layer that allows you to do things like linear algebra and so on and so forth. And you can see how this comes together in the following diagram. At the top there, we've got our pre-made models, which are sitting upon our layers API. That layers API sits on top of our Ops API, and this understands how to talk to different environments, such as the client side. And by client side here, we mean things like the web browser. Now, those environments themselves can execute on different backends. And in this case, we can execute on things like the CPU, which is the slowest form of execution, WebGL to get graphics card acceleration, and WebAssembly, or WASM for short, for improved performance on the CPU across mobile devices. And the same is true for the server side as well. We can execute using Node.js on the server side, and this can talk to the same TensorFlow CPU and GPU bindings that Python has. So yes, that means you get the same AVX support and the same CUDA acceleration that you do in Python. And in fact, as we'll see later, this means the performance benefits are pretty much exactly the same as well. We execute as fast and in sometimes faster than Python for certain use cases. Now, if you choose to still develop your machine learning in Python, which many of you of course will, that's completely fine too. Our Node.js implementation supports the loading of Keras models and TensorFlow Save models without any kind of conversion. So as long as you're executing on the server side in Node, no conversion is required to use that and integrate with, say, a web team. So very convenient. And then if you choose to take your saved model and you want to run that in the web browser, then you'll have to use our TensorFlow.js command line converter to do so. That will convert the saved model format into the .json format we need to run in the web browser. And that's only required if you want to run client-side in the browser. So let's talk about performance. Here we can see for MobileNet v2 the average inference times for GPU and CPU. Looking at the GPU results there, you can see that for TF Python, we get a result of 7.98 milliseconds, and for Node.js, we get 8.81. So basically within a millisecond of each other, which is basically the same result. Now, the key thing to note here is that if you have a lot of pre and post processing and you convert that to be written in Node.js, you'll get the benefits of the just-in-time compiler that's unique to JavaScript at runtime. And this can lead to significant performance boosts outside of the inference alone. So let's see how Hugging Face used this. So here we can see how Hugging Face converted their Distilbert model to run in Node.js. They basically converted the pre and post processing layers to be written in JavaScript in Node, and this led to a 2x performance boost over the Python equivalent. So what's important to note here is that we are using the saved model from Python, but by converting the pre and post processing layers, it gives us a 2x speed increase because of the just-in-time compilation of JavaScript in Node. And on that note, if you are thinking about executing on the client side, there's also some superpowers to kind of consider here as well. And these are hard or impossible to achieve on the server side in Node or Python. So the first one is privacy. If you're executing on the client side completely, then none of the sensor data is going to a server for inference. And that means the client's privacy is completely preserved. And that's very important for certain types of applications like medical or legal, or if you're trying to comply with certain rules such as GDPR, where you might not be physically allowed to transmit data to a different server. Second point, if no server is involved, you can achieve lower latencies. Typically, it might take 100 milliseconds or more if you're using a mobile device to talk to a server and get the result. If you're using TensorFlow.js on device, you can cut that middleman out and essentially have lower latency for your inference times, resulting in a higher frames per second to allow real-time applications. The third point is lower cost. Because no servers are involved, you can save significant costs on hiring GPUs, RAM, and CPUs, which might be running 24/7 for a busy machine learning application. By doing this all on client side, you don't need to hire those pieces of hardware in the first place. You just need to have a standard web CDN to deliver the website. Fourth point, interactivity. JavaScript from day one has been designed to present information in a rich way. And we have very mature libraries for 3D graphics, data visualization, charting, and much, much more. This allows you to prototype very complex things very, very quickly. And this is one of the advantages of using JavaScript. And then the fifth point is the reach and scale of the web. Anyone in the world can click a link and use your machine learning model in a web browser. The same is not true if you want to do this in Node or Python, because first of all, you have to understand how to install Linux. Secondly, you need to install TensorFlow. Then you need to install the CUDA drivers. And then you need to clone the person's GitHub repository, read their README, and if all of that works in your favor, then you might have a chance of running their machine learning model. So you can see how there's a much lower barrier to entry here if your purpose is to get your research used by many people around the world. And that can be really great because it can allow you to identify biases or bugs that maybe could have gone overlooked if only 10 people were using it instead of 10,000. And of course, with TensorFlow.js in the browser, we can run on GPUs on 84% of devices due to WebGL. We're not limited to just NVIDIA graphics cards, we can run on AMD ones too, and so on and so forth. And if we look at the server side, we can also see some of the benefits of running in Node.js. It allows us to use the TensorFlow saved model format without any kind of conversion or performance penalties, and we can run larger models than we can do on client side. There are of course some GPU memory limits you might run into if you try and push a gigabyte model over the web to the client device. Third point, allows you to code in just one language. If you're already using JavaScript, this is a big win. Currently, 67% of developers use JavaScript in development already, according to the Stack Overflow 2020 survey. And there's a large NPM ecosystem for Node.js with lots of modules and libraries coming out all the time, so great community support too. And then fifth point, performance, as we spoke about, we've got the same C bindings as the original TensorFlow in Python, which can be used to get parity for inference speeds. And we've got the just-in-time compiler boost for the pre and post processing if you choose to convert that over to Node.js. So with that, let's wrap up with some resources that you can use to get started and learn more. If there's one slide you want to bookmark, let it be this one. Here you can see all the resources you need to get started with TensorFlow.js. Our website at the top there, you can find many resources and tutorials to help you on your way. We've got our models available at tensorflow.org/js/models. I've only shown you 3 or 4 today. There's many, many more on there which you can also be using out of the box to get started super fast. We're completely open source, so we're available on GitHub as well, and we encourage contributions back to the project if you are feeling ambitious. We have a Google group for more advanced technical questions, which our group monitors. And of course, we've even got CodePen and Glitch examples to help you get started with boilerplate code to understand how to take data from a webcam and pass it to some of our models. So with that, you can get started very, very quickly. Now, if you want to go deeper, our recommended reading is Deep Learning with JavaScript by Manning Productions. And this is written by folk on my team and the TensorFlow team itself. It's a great book, and all you need is some knowledge of JavaScript. It assumes no prior knowledge of machine learning, and is a great resource to go from zero to hero. And with that, I encourage you to come join our community. If you check out the Made with TFJS hashtag on Twitter or LinkedIn, you'll find hundreds of projects that people are creating every single week around the world. And I can't show them all in the presentation today, but here's just a glimpse of some of the great things that are going on elsewhere in the community. So my last question for you is, what will you make? Here's one final piece of inspiration from a guy from our community in Tokyo, Japan. He is a dancer by day, but he's used TensorFlow.js to make this really cool looking hip hop video, as you can see on the slide. And my point for saying this is that machine learning really is now for everyone, and I'm super excited to see how everyone else in the world will start to use machine learning now that it becomes more accessible. Artists, musicians, creatives. Everyone has a chance now to use machine learning, and if you do, please make use of that Made with TFJS hashtag so we can have you featured in our future presentations and blog post write-ups. Thank you very much for listening, and with that, feel free to stay in touch. I'm available on Twitter and LinkedIn for further questions, and I look forward to talking with you soon. Thank you.
Wow, very nice to see some JavaScript here. I could kind of understand what was going on. So thanks a lot, Jason, for bringing some JavaScript to this conference. Before we get Jason on the stage for the Q&A, it's that time again. We're going to first start with the claps in the community channel. So let's give it up for Jason. I'm checking right now if you're chatting, if you're sending the claps. Send the claps. And another thing, of course, we have another poll for you. So grab your phones or another browser tab and go to menti.com. Enter the code 566754 and answer the following question. Do you plan to use TensorFlow.js in a real-world use case? So once again, go to menti.com, enter the code 566754 and answer the question. We're going to see the results right after this Q&A session with our friend Jason. Jason, please join me on the stage.
Well, thank you for having me today. Great to be here.
Well, really happy to have you. My first question, and the question is from me, is how many cameras do you have? It felt like you have like 6 cameras going on, all different angles.
I've got definitely more than 2 cameras here. It's very good for demos and doing things in the web browser, and I'm recording at the same time, so good stuff.
Yeah, it was nice to be able to enjoy your glowing microphone from 6 angles. So yeah, thanks a lot for your awesome gear setup.
It makes the ML train faster if I've got RGBs, right? So good stuff.
Okay. We can train on that. So we're going to go to a question from the audience. Is TensorFlow with JavaScript the new wave? Do you think it'll be bigger than using TensorFlow with Python at any point?
So if we look at just the number of developers that use JavaScript, currently, I believe 69% of professional developers use JavaScript in production. So if we're looking at just pure numbers of developers that exist that use JS, there's definitely a larger audience than, say, Python. Will all of those JS developers use machine learning? That's the bigger question, of course. But I do think as time progresses, people will realize how they can use it in the web environments to unlock new things for their clients and so on and so forth. So as it grows, I do believe it has the potential to maybe become more widespreadly used than maybe the Python version, but time will tell how that goes, I guess. So it depends if people start using it more in web environments. Yeah.
Yeah, so for me, I am a web developer, and it sounds scary to me to go into machine learning. I mean, I just want to move boxes around and make media queries and responsive websites. And then you're saying basically, if you have that knowledge, if you can do JavaScript web development, you can do machine learning with TensorFlow.
Yeah, I mean, you don't need to have too much of an ML background to use our pre-made models that I spoke about in the presentation today. As long as you know some basic JavaScript, you know how to call a function, basically, you can then get some results back and then do with that as you wish, just like you would use any other black box API from the internet or something like this. So it's super easy to use for people to get started with. But for those of you who have more of a machine learning background, maybe you're already doing it in Python, and you just want to get the reach and scale of the web, because that's something that you might not get if you are doing it on the server side only in your own custom environment, and you're not scaling it out to millions of people, then there's some other advantages you can get by doing it using TensorFlow.js on the client side, such as the privacy and all these other things that we spoke about in the presentation. So I think use the right tool for the right job. And if your goal is to make your cutting edge ML research kind of popular and accessible to the whole world, then JS is a great way to do that, because people who are not so technical get a chance to then use your amazing research. And I'd love to see more of this coming together between the two communities. So imagine if some like musician or artist or creative could take that amazing research you've done and apply it in a very different way to maybe what you originally envisioned, but to create some great innovations nonetheless. Kind of like the clothing size estimator that we saw today, but I created in a few days. And the original person who created body pics may not have thought of using it in that use case. But of course, when people have problems in their lives, they'll come up with very creative solutions to those problems. And I'm looking forward to see what happens in the future with that too.
Yeah, so basically people can make a cover album. So a follow-up question to that is, how important is it, if I want to start using TensorFlow.js, to have a good understanding of math?
It's just the same as Python-based machine learning. Obviously, if you want to go down and unpeel all the layers of what's going on behind the scenes, you're eventually going to find a lot of the linear algebra and statistics and all this kind of stuff that drives all of this stuff. So if you want to go lower level, then of course you need to learn some of the mathematics to start tweaking things. But if you are working with the pre-made models or other research people have made, often a lot of this stuff can be reused. I think maybe 5% of people will probably ever need to actually write their own custom model from scratch. Most of the times you can reuse existing research. If I want to do like face landmark detection, we've got models for that already. I don't need to reinvent the wheel there necessarily, unless I need to understand different points that aren't available in that current model. At that point, I need to start diving into this to start retraining it on my custom data to learn how to recognize those things. But if you don't need to do that, then you can do very well without going too deep into the pile there. Yeah.
So okay, so it's easy to tip your toes without it being all too scary.
Yeah, I think no matter what your level, everyone has a chance to play with TensorFlow.js. And the people who want to go deeper, all the goodies that you're used to from Python land also exist there. We've got a very similar Keras-like API, and then also the lower level mathematical API also exists, just like the original Python-based version of TensorFlow. So no matter what your level, you can go full into it, or you can stay at the high levels and have a more abstract view of it all. So yeah.
Yeah, but it's basically anything you learn, right? You can kind of tip your toes in and it will be okay. And the more familiar you get, you can go deeper and deeper and down the rabbit hole, basically.
Exactly. And I think that's the way to go, honestly. Like, I think a lot of people start off on the high level. They find something they're passionate about. They start tinkering with that, and then they want to optimize it in some way or adjust it slightly. And it's at that point they start to go a little deeper into that kind of field. And, they make great things. So yeah, little by little, people will go in the right direction as they need to, I think, and explore as they need.
Yeah. Okay. We have another question. How long did it take for you to become a machine learning expert as you are? So how long have you
I don't consider myself an expert. I'm still learning every day. I'm always inspired by the amazing things that are coming out from the rest of the community and colleagues. So I've got a long way to go on my journey for sure. I think I just use machine learning in creative ways that people might not always think about. So some of the demos I showed today, for example. So I think I get known for those kinds of things, but my machine learning journey, my background is actually web engineering, and it's only the last 3 or 4 years that I've actually started exploring the machine learning side of things. And I was very fortunate to get this role being the developer advocate for TensorFlow.js, where I can now have a chance to go much, much deeper onto the ML side, as well as still enjoying my passion for JavaScript as well. So yeah, I've got a lot of learning to do ahead of me, and I'm excited to do all of that with all of you as well, and hopefully share my learnings as I go.
Learning in public, that's fun always.
Yeah, exactly.
So next question is actually from my co-MC Sergey. Python has a big tool set of explorative data analysis pandas, Jupyter, Matplotlib. How is it for JS? What is the biggest bottleneck for JS community to deep learning?
Yeah, so obviously we are much, much younger than the Python community. We're only about, well, just over 3 years old compared to TensorFlow Python, which is more like 6+ years old now. However, we are starting to see our JS community port some of these things over to JS. So there's a library called Dantho.js, which is essentially inspired by Pandas. And people are starting to make these tools and things in JS now as well. And of course, we'd love anyone who's interested in helping us make and replicate these things in JS. Please do come contribute. We're open source. And of course, for these other things, you don't have to be contributing to TensorFlow.js itself. It could be a standalone library. And now is a really good time to get involved because, as I mentioned, 69% of developers are using JavaScript, and they're just starting to get their feet wet with machine learning. And this could be a big opportunity to make the library that everyone uses 5 to 10 years from now, when it does become more mainstream in the JavaScript community. So this is a great opportunity to be on that bandwagon, if you will. But yes, we're starting to see the community build these things organically, and I'm sure that's going to continue to improve with time.
And this is a question from me again. How would you say job security is? Let's say I drop everything and go full in TensorFlow.js, I don't know, a few months of studying. Job security, how is it?
I mean, machine learning, generally speaking, is in demand. I think most people at this point in time would associate machine learning with Python-based roles, typically, especially at the more academic kind of institutions and research areas, even at Google, for example. However, I think it depends on the needs of the company you're trying to go to. Like if it's some kind of web startup, maybe they make content management systems or something like this for websites and stuff like this. And maybe they want to have a differentiating factor to make them stand out from the crowd. They might employ someone to put some smarts into their web stack for that content management system. Maybe you could have auto text summarization or smart cropping of images when people upload images. And all this stuff can be done now in JavaScript very, very easily using some of the models we've seen today. And yeah, basically, I think these jobs will grow for sure as people become more aware that it's actually possible to do in the browser. We're still at the very early stages, as I mentioned, but as people's awareness grows, so will the jobs and other things that come with that.
Yeah. So, okay.
But yeah, learning the skills now is great for the next few years when those jobs start to appear, when people actually will need this. Because as a JS developer, we're in a unique position that we, when we make a website, that website could be for pretty much any industry out there. It could be for a farmer, it could be for a fashion brand, it could be for anything. And all of these different verticals have the potential to be optimized in some way using some kind of ML flow. So for fashion, maybe it's something like the clothing size estimator. For farming, maybe it allows them to automatically kind of send goods to the right place by categorizing apples and oranges or whatever it might be. So like, there's potential for ML to be injected into their pipelines. And maybe there's room for something on the web kind of platform too, for a more seamless, frictionless experience where you don't need to install an app. A lot of people don't have the apps of the brands that they might use. They just go to the website. So in that case, there's one touch point that might need to be optimized using machine learning in that use case. So things like that might come out in the future. Yeah.
So JavaScript developers that are watching, you heard it here first. It's good for your job security. Learn TensorFlow. I have a question from Jeroen. Will TensorFlow.js make the server-side TensorFlow serving system obsolete?
No, I think it will work hand in hand with these things. So as I mentioned, it depends on your engineers and what they're used to. I wouldn't say we want to start any language wars here. I think if you know Python and you're familiar with Python, go and use it for sure. But if you're integrating with a web team, then maybe the web team will be using Node.js. And in that case, they might prefer to load your Python model in Node, which you can do with TensorFlow.js on Node. And that you can do that without any conversion, in fact. So it makes integration with other teams a lot easier, maybe, depending on the stacks that they are already using. And a lot of web engineering teams will be using something like Node.js. And we also saw today that by converting the pre and post processing layers of your whole stack, of your ML stack, if you convert that to Node, you can actually get the benefit of the just-in-time compiler of JavaScript that we saw with Hugging Face for their Distill-BERT implementation. It led to a 2 times end-to-end speed increase in performance, which is great just by converting to JS on in Node.js on the server side. So I think it depends on your use case and your team's knowledge and all these kinds of things. So I don't have any strong preference between using one or the other, but using the right combination may depend on your situation and what you're trying to do. Yeah.
Okay. We have time for one short answer. This is a question from the user Quest. Very inspiring talk. When you talked about the security benefits of running TensorFlow.js without server, is it possible to keep everything off the server, or are there things that wouldn't work without the server? 1 minute, go.
So yes, if you're running on the client side, then everything is completely off the server other than the initial delivery of those assets. So in that sense, it can run completely offline if you use something like a progressive web app or something like this. So yes, you can do it completely serverless if you choose to do so.
Cool. Well, thanks a lot, Jason. Just as a reminder, Jason is going to go to his speaker room now. If you have any more questions or want to just hang out with Jason, go to the spatial chat, find the link below in the timetable. And thanks a lot for joining us, Jason. And yeah, I might just get my hands dirty this weekend.
Excellent. I look forward to seeing what you see, what you make, sorry. And thanks for having me. Cheers.
Bye-bye. All right, it's the time. We're going to go to the results of the poll. So once again, the question was, do you plan to use TensorFlow.js in the real world for a real world use case? And the results are, can I get a drum roll? I'll get my own drum. It's 70% for yes. That's a lot. So a lot people are inspired. 27% bit in doubt and just 3% no. So that's neglectable. Really nice to see that Jason inspired so many people. And yeah, like I said, this was the last talk. So like we mentioned in the opening, we have a competition about the GitNation multipass. All you had to do is send a photo on Twitter using the MLConf EU hashtag, and we would select the best photos. So we're going to look at the photos now together. How are you feeling, guys?
Feeling good.
Yeah. Are you ready to look at some photos?
Let's look at some photos together.
Can be better than selfies after the conference.
Yeah. So we have a collage, a beautiful collage here. And there's someone watching by the monitor. Oh, 2 monitors. Whoa, that's some pretty purple lights you got there.
Honestly, all of our setups are just more extravagant than my. Here I am with my little laptop trying to pretend I'm like this arch coder. I'm like, I just need my little hoodie and a dark room with some green text just going up and down. Go to MS-DOS and just yeah.
I'll be my terminal. Yeah, these are nice setups. So thanks for sending your photos. We have a few more. I mean,
yeah. Oh, the cute
dogs.
Puppy. Oh my goodness, they're wonderful. And wow, some really crazy setups you guys have. Love the broken laptop. I love that setup. Just like broken laptop. That's me right now, literally watching this conference. Oh man.
Oh, someone is chilling on the bed. That's always nice. That's nice. So to find out who is winning, we have a nice wheel of names prepared.
Ooh, I love wheels.
Yeah?
Yeah,
so
let's spin it.
Oh. So the wheel is not ready yet. I just heard from Houston, we are not ready yet. So, Sergey and AJ, how do you feel about today? Are you happy, or are you like, can't wait for tomorrow? I'm not done yet, I need more.
Yeah, I mean, the conference was so amazing that you can even see that dogs were watching that, right? Not even humans, right? The dogs now learning machine learning. So I think it's a great success. What other conference were watched by animals?
Oof, I want to learn. Oof, machine learning. That's
let the dog out.
You know, like this kind of reminds me, it's like, okay, all this excitement and build up in this tension is kind of like Wheel of Fortune. I'm not sure if you guys watched it, like around here. It's a pretty popular TV show. It's like, oh my God, all that hype of just like, will you get bankrupt or will you win $1,000? Here, we should spin the wheel right now.
Well, here you don't go bankrupt. You don't win $1,000. You just win the Git Nation multipass. You know that, right?
Oh, is that the prize? Oh, I totally knew that. Here I applied.
Pay attention, AJ. Pay attention. Yeah, I have to say I was really inspired today. It's fun for me to see a whole different type of technology that I'm not familiar with, and I was really happy with it. So I'm really looking forward to tomorrow also.
Definitely. I think like when going into this, I think you said like, hey, what is it with machine learning? What's all this hype about? And I think like Metin, you kind of got into that initial stream of curiosity, which is actually very healthy for anyone that's trying to get into the field and even progress throughout the field too. The more curious you are, that pushes you to kind of understand and learn more about the field, and then your knowledge just keeps going on and it's a cycle. So good job. Do you feel like you've accomplished something, Metin, today? You think you're a little smarter in the field of machine learning?
Well, we'll have to see, because touching it is always different than just leaning back and watching, of course. But yeah, luckily I've started at a company, like I said, that uses machine learning, and really looking forward to seeing what's going on a bit more in depth.
If they were to actually create like this little model to classify dogs as a cute dog or an ugly dog, and you just took like that picture right over here with the two dogs over here, do you think that's all cute dogs? It's like, it's always going to be cute dog, or cute dog and cuter dog?
I mean, your data set is going to be super unbalanced, right? Because all dogs are like super cute, right?
That's actually true.
Yeah, we're just throwing a cat there. I just heard from Houston, and we are good to go with the Wheel of Names. So are you guys ready too?
Let's do it.
All right. So we have all the usernames here in the wheel. It's all prepared. I'm just gonna click to spin it. So if you see your name here, you're one of the 8 people that we've shown. We're gonna see if you've won.
Let's go.
Let's go. Wheel of Names Fortune. It's gonna be Dimitri Store _com.
Woo-hoo! First
Congratulations.
You.
The organizers will be contacting you through Twitter on this handle. Enjoy all the conferences and hope to see you in the next one. Now we're gonna go, because we have 2 tickets available, like we mentioned. So we're gonna go to the next one.
Let's get that
the previous winner.
Let's get the wheel spinning. Come on, let's do it. Woo! Woo! Yeah!
You should also make some sounds, the wheel.
Ding, 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 ding.
Ding, ding.
Oh,
wait, what is this? Oh, it was just on the line. Samuel.
He was a more lucky one.
Yeah.
Lucky. So once again, Samuel, you'll be contacted through Twitter. So be sure to check your DMs.
Congratulations to our winners. Woo! Conference multi-passes.
Yeah. Hope to see you at the next conference.
Yeah, that's going to be actually very helpful. This is one of my first conferences here, and I'm having a blast so far. So I'm sure like the future ones will be like totally worth it.
Well, I hope to see you at the React conference then. I can teach you something in my world. So it's time, ladies and gentlemen. We're going to start the after party right now. So there's topic-based rooms for networking on spatial chat, and there's the Quake.js tournament. So if you want to shoot, if you want to talk, we got you covered.
And before we leave, we have another thank you. We need to thank our sponsors, okay? Our sponsors are what help this conference and so many others that we'll have in the future even possible. You're all watching this because of our venerable sponsors that we have here.
What helps to make things better is obviously more data, right? More data for machine learning means like better predictions, more data for people organizing conferences, meaning even more amazing conferences. So please open your browser, right? Go to MLConf EU/feedback, and there put all of your honest feedback. What did you like? What did you enjoy? What kind of doc you enjoyed the most on this winning picture, right? And send it to us. Like hopefully next year, we're gonna have it even more exciting, more amazing, and better conference than this year. I mean, it's gonna be hard, but we're gonna start somewhere.
So right now, we want to show you how the speakers are all watching. So we're gonna invite all the speakers to the stage that are still awake, of course. Hey, everyone. Oh, we see Jason. Yeah. Yeah, Jason is still in his discussion room and you see him discussing. That's nice.
Yay. Hoot, hoot.
Thank you everybody for joining us for such a different locations and different time zones. It was like a blast having all of you here.
Yeah, it's amazing. Like this is like the only type of conference where you would see like on one screen, so many people of different diversities, genders, cultures, backgrounds, just coming right here to fit onto a little live stream to give very educational talks. And honest, I don't know about you guys, but actually I think I could speak for everybody here that we all learned a thing or two today.
Yeah, definitely. And you know what is even more amazing about this one? That tomorrow there is like entire full day of more speakers, right? So please get excited about the next day and even more speakers. And definitely thank you all of you who did join on the screen as well.
Yeah.
Please wave to your audience as well.
All right, we're gonna be closing off for today. I hope to see everyone again tomorrow. Same time, same place, different talks, same MCs.
Be here, we'll be here. I hope you will too.
Before that, I heard that Metin is like super amazing in Quake.js. So if you wanna kick this MC out, right, go to your browser, your Quake.js tournament, and hopefully have some blast before tomorrow, because tomorrow is gonna be about learning.
Out for it?
Yeah, sorry, I heard that you're good, right? So
he's good. He's not that good. Come on, let's.
Okay. So there's gonna be a competition between like AJ and Metin, maybe.
Let's do it.
All right, everyone. See you tomorrow. Bye-bye.
Have a good one.
Bye.
It was a pleasure.
I'm walking alone. Tonight, we will fly above the sky. We are heroes tonight. Yeah, we are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah.
suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire. suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Heart on fire. Set my heart afire.